Before I forget, who was outside my class, my office, 20 through 50? What section was that in? Remember that 20 through 50 is supposed to be every fifth one?
Was it?
Yes.
Thank God, because I was sitting there.
Yeah, yeah. Do you remember what section that was?
It's sorry, I was listening to 2.6.
2.6, okay.
It was so
Guys. If you listen, I'm going to cut your homework down. There we go.
Even more?
They normally get.
Even more. What do you?
So I'm going to tell you what it's supposed to be. So 2.6, it says 20 through 50. Yes? It's supposed to be every fifth one. It doesn't say that. So some people were like, man, this took me a while. And we're like, oh shit, I didn't mean. So again, that sheet was made by me. I'm a human. I'm going to make mistakes. So if you see something like, I'm never going to assign to you like that many freaking problems. That doesn't make any sense. Just ask me, not a big deal, right? That reminds me.
Every fifth one, right?
Every fifth one, yes.
It's like we're in a movie.
I'm going to play with this for a minute. What's your name again? Miguel Martinez. Somebody put a comment on the video saying the glare makes it hard to see. Right? I don't want to turn the lights off because there are students in here who maybe can't see in low light. You know what I mean? If I could just get this damn thing to turn off, that would be amazing. Back in the old days, we had a switch and it said overhead. And you click that and only the overhead light turned on.
Well, we're in the new days now, so.
Yeah.
I'm just kidding.
So what's supposed to work doesn't work. So I'm curious.
Did you try all right?
That's what I'm doing right now. Yeah.
Almost.
Now, please be honest with me. If I left it like this, is this too dark? All right. So either we see the screen and melt, or we leave the door open and not see the screen.
Melt.
So what's the question?
No, I was gonna say you could put the camera on that side, but then they wouldn't.
Then I won't pick up my voice as well. Yeah. So it's a. Say again. That door should also be open to make a flow. If we only have one door open, it won't really flow. Yeah. So the math department, we're happy to have a building to complain about. We didn't used to have a building even to complain about.
Over there. Could you move the table? I just never did. If you move the table to the right, there's not as much of a glare from that position.
Yeah, the glare is coming from you. If I make it like an extreme angle, maybe. All right. All right, so I'm gonna put this over there. Okay. All right. Well, plus the lights are out at the moment, so. The question is number 6.
Oh my God, that's the exact question I just asked you.
That's funky. So this one says, find a reason to change the length of the curve. Okay.
What section is this?
This is 2.7.
2.7.
Because I need help with that too.
What to do with you? All right. Here's what I'm doing. You're going to go there. And And you're gonna go there. Okay. As long as it's away from you. Guys, so tangent line, what does that mean? What's a tangent line? The line with a slope. What is? Be more specific. A slope.
The slope at any given point.
One that touches the function.
Yeah, the line that touches that point that has the same slope as the function at that point. I love it. So visually, you can tell if it's a tangent line pretty well, because it kind of touches the point, it touches the curve at that one point, keeps going, yes? You with me? You kind of trace out what the tangent line's doing as you go around a curve. We've done that before. Beautiful. To find the equation of any line, I don't care what kind of line it is, what two things do I need? Line intercept would be awesome, I don't always have that. I need a point and a slope. Cool. So, do I have a point?
Yes.
Sometimes I have a point. In this problem, I have a point, yes.
Yes.
Do I know the slope?
No.
Yeah. Do I have a process to get the slope?
Yes.
Yeah, it's the entire first act of calculus is all about that, yes? Okay, so at this point, in section 2.7, do we know the shortcut that we learned in 3.1 yet officially?
Oh, wait. Oh,
So,
no.
do you as a person know the shortcut?
No. Yes.
You as a person, you know the shortcut?
Yes.
When you were doing section 2.7 homework, are you allowed to use that shortcut?
No.
Oh,
No.
If you do, know it. So I love it when I have teacher pre-calculus and I have students doing calculus to solve the problems. I'm like, even if you know this shit, you can't use it because you're not in calculus. Are you guys with me? Now you are, but you still can't use stuff you learn later. So, what process do I use to figure out the slope of this function at x equal 1? Sure. I love that you always go back to that.
F of x plus h.
Ah, there you go. The limit is h goes to 0 f of x plus h minus f of x over h. Now, I love it. I do love it. I also don't love it, but I love it because that is just y2 minus 1. That's all that is. But don't say much of it. We're past that. Now we have a better, more broader interpretation of slope. Are you guys somewhat with me? Yes.
So if we did the y2 over y1, like, would that be incorrect? Because
Well, sort of, because what's your y2? I know y1.
Oh.
What's y2?
Yeah, I
I can't be specific here because what I really need is 1 point. And to compromise with that, we got the limit as h goes to 0. Are you guys with me? What does that part of it do for me? Limit as h goes to 0. That takes the 2 points and brings them together to be 1. You guys kind of with me? That's the whole idea. I need 2 points to find the slope. I let there be 2 points, but I just get closer and closer so I can see what the slope right at that point is. Okay, I like it. Yes?
Does that mean you do it twice then?
No. Why would you do it twice?
I would.
Okay.
Because I don't know.
I don't know either. So, I'm just trying to find one slope here, correct?
Yes.
Yes, so I only do it once.
Okay.
So remind me, what's the... Oh my goodness, so much crap up here. Alright. So the process is the limit. H goes to 0. Of x plus h minus f of x over h. Now, let's be a little more specific. I don't want it everywhere. I'm not going to put x, because if I put an x, that means I'm going to figure it out everywhere. For this problem, I just need to know the slope at 1. So I'm going to improve upon this. Can you figure out what f of 1 is? Do you have to figure out what is f of 1? They already did that for me. Thank you, book. Do you know what f of 1 plus h is yet?
No.
No. So then you figure that out, you plug it in, yes? You guys kind of with me? So before we get to chapter 3, if you see a question about the slope at a point, or a question like this one that needs the slope at a point, tangent line needs the slope at a point, you must do this process. Are you guys with me?
Yes.
Because that's all we know. Chapter 3 is where we start to go, this thing sucks if I want to do it forever. Oh my God. Can we make some shortcuts? So chapter 3 is where we're going to learn some shortcuts. Okay. Is everybody with me? So on the test, I normally say use the limit definition of slope or limit definition of derivative. I've said that at least one other place before now. This is the limit definition of derivative. Yes? Okay, I like it. Okay, is that all? Okay. If you want me to do it, no, I'm not going to. Now you know how to do it, so do it. Has anyone tried this and gotten into trouble on that problem number 6? Or did most of you guys that had trouble with this not sure where to start? Is that what
No,
it
I
was?
just wasn't sure what to do.
Gotcha.
So how did you get that one in there again? Is it just plugging in,
Yeah, where'd that 1 come from?
X1?
The original coordinate.
Yeah, it's telling me they want me at x equal 1, yes. Yeah. Now, could you do this? Yeah, you could. And then could you just plug a 1 in for x at the end? All day. Okay, I like it. Maybe.
What about something like 7?
Same idea.
All of them are the same idea?
All of these are the same idea.
Okay.
They all ask the exact same question. They all need the exact same thing. What do I need for each one? A point? I've got a point for every one of them, yeah? And the slope, oh shit. None of those are straight lines, so I must use the limit definition of slope for that. That's the only way to find the slope of a curvy dude at a point.
Okay.
This one would be exciting. This one would be what you might call gross. Can you guys see that? Anyone can tell me what f of x plus h would be?
That.
X plus h plus 2 over x plus h minus 3.
Over H?
Well, minus f of x over h, yeah. Right? Okay. But I don't think I signed number 7, so be very happy I didn't. Okay. Today we're going to learn the shortcut for this, by the way.
But we can't use it.
Can't use it, no. Not if I assign number 7. Yes?
Can you do chapter 3.1, number 63?
Let's see. Oh, cool. Right there. So it says find equations for 2 lines that are both tangent to this curve and parallel to this line. Okay.
Is it just asking for the anti-parallel?
No.
The one pointing up and one pointing down?
No, because they both have to be parallel to that line.
It would be. It'd be going opposite direction.
So guys, help me out. What's true about parallel lines? Any 2 parallel lines, what do you know is true? They don't touch, so therefore what's the same? Slope is the same, kick ass. So doesn't it seem important that this hinges on my answers being parallel to this? So won't that tell me what the slopes of my line should be? You guys all with me? No. Can somebody tell me what the slope of this line is? Are you sure?
Fine.
Is it, I'm not saying you're wrong, but I want you to be right for the right reason.
Yes.
How do you tell the slope? Don't you have to get y by itself?
Yes.
If you add y, subtract 15, that's still 3, yes? But be careful. It's not just the number in front of x. It's got to be y equals mx plus b. Or in this case, if I get y by itself, the 3 is just sitting there, so of course the slope is going to be 3. Are you guys all with me? If that was a plus y, and you said the slope is 3, you're wrong. Because then you have to subtract 3x to get y by itself, then it would be negative 3, so everybody with me? So I can tell the slope of a straight line easy as shit if I just get y by itself. Because then it falls into place, mx plus b. It falls into place. You guys all with me? You gotta be with me. Whole part of calculus is doing stuff beyond lines, so we have to be like really super good with lines. So let lines be easy. This problem is awesome. I love this problem. And I'm not sure how that makes you feel. You're in chapter 3, yes? This is section 3.1. Can somebody tell me the derivative of this? 3x squared
3x squared minus 6x
minus 6x.
plus 3.
And what does that represent?
The slope.
Slope. And what did we just say the slope has to be? What's
Equal.
it has exactly what does the slope have to be?
3.
Our answers are parallel to this line, correct? Let me write some shit down. Our answers are parallel to that line. Isn't that what that says? What is this line slope?
3x minus 15.
And what is the slope from this?
3.
3x squared.
Minus 6x plus 3.
This is the slope, correct? And we know the slope is supposed to be 3. So what does this have to equal?
3.
Frickin' 3. How many answers do you get from that when you solve it? No.
2.
Fundamental theorem of algebra. The number of answers you get have to match the degree of the problem. So I expect 2 answers. Say again?
Why is it not solved out that way?
What do you mean?
Well, you end up with the 3's cancel,
Totally?
one of the x's divides out.
No. All right. What can you not divide by? What? True, but why not? What number can you not divide by?
0.
Could x be 0? So you can't divide by. Huh? Clever trick? Not so clever because you lost an answer, right? So is everybody with me so far? If the hardest part of this problem is to realize this is what you're able to do.
So do you have to factor that in order to?
Well, you have to solve it. So you're right. So subtract 3 and then factor. Yes.
Wait, because I'm confused as to how you got 3x squared minus 6x plus 3.
So now we know the shortcut. How do I take the derivative of x to a power? The power comes down and it goes down by 1. That's the shortcut we learned. Yeah. Power comes down, 2 times 3 is 6, goes down by 1. 1 comes down, or you just say, what's the slope of this? 3. And what's the derivative of any constant? 0, because it's flat. It's got 0 slope. Or you can say, isn't there next to the 0? Is everybody cool if I do that? Because that's 1. If the 0 comes down, doesn't that become 0? So every constant's derivative is 0 because it's got a flat slope. Or you can think of it as a 0 power that comes down. Is that all right? Yes? Yes?
I was gonna ask you, did you work out the algebra portion?
Maybe. Let me say this. I want to really make sure everybody understands the first part of this. I need tangent lines, correct? Doesn't the problem give me 2 ways to figure out their slope? Here's one way. Their slopes have to be this. Yes? You guys with me? The slope of the tangent line at a point of a function has to equal the derivative of the function at that point. Holy shit. Another name for derivative is slope. So when I take the derivative of this represents the derivative of the function everywhere, correct?
Okay.
They also tell me my tangent lines are parallel, so that the slope's got to be 3. What did we just say? That's the slope function. Well, it's got to be frickin' 3. That's what the problem tells me. It's got to be 3. So whatever expression I have that represents the slope must be equal to 3. That's what the problem says. Do you guys see that? There's going to be some other problems like this. And I love these kind of problems. I would. Yes?
So since the slope is 3 and the tangent is equal to the slope, you just have them equal to each other?
The tangent line needs to slope at a point. This process gives me the slope at every point, correct? If I do this process, that's the slope at every point, correct?
How do you get 2 answers? Like you
All right.
get 1.
I need to make sure everybody's with me on the concept before I do the specifics. When I take the derivative of something, I am getting the slope of the function at every point. Is that true? Yes. I could have just gone crazy. I could have just been going crazy. I'm a human. Who knows? I could be making a mistake. Does everybody agree with me? Okay. Enough of you do. Okay. That's the slope, and I know it's supposed to be 3 because I'm supposed to be parallel to that line. Okay. Now, please tell me. Solve that. If you haven't done it yet, solve that. And if you're not sure how to do it, still try. Somebody already gave away the first step. Subtract 3, yeah? Because what do you need this side to be? Why?
So you can factor it
Because there's a higher power than 1. If that wasn't there, would I care about getting this side to be 0? No, I would just solve for x. So when there's a higher power than x, I can't put these together. I need to get it equal to 0 so I could do that whole process of factoring. Yes? Okay. So when you subtract 3, these go away, yes? So you get 3x squared minus 6x equals 0. How do you factor that? Pull out 3x. X minus 2. So either 3x is 0, which means x is 0, or x is 2. You get 2 factors, you get 2 answers. Now, does that answer the question? Nope. Sorry. We just got 2 x values, yes? All right, let me see if it. Do y'all agree with me that as I move along this function, the slope is constantly changing, yes? Do you all agree with me that if I have a cubic, I know camera, you're fine. Let me do it over here. If I have a cubic, like a very general cubic looks something like this. Does everybody agree with me that there could be 2 places where the slope is 3?
Pull it down.
You guys see that? Didn't we just discover, now our function doesn't look like this, but what are those 2 x values for our function where that's true? 0 and 2. So for our function at 0 the slope is 3, and at 2 the slope is 3. So this problem says, okay, here's this thing. Let me try to make it look sort of like, yeah, this will work. All right, if I kind of force this to do it. So that's 2 and this is 0. So I want sorry, I hate overheads, but too bad for me. So I want the tangent line where the slope is 3. How do I know that from the problem? Because they told me I had to be parallel to the line with a slope of 3. So I know the answer has to have a slope of 3. Do you guys see visually now why there could be 2 answers for that? Yeah.
So then do you just plug in 0 and 2 back into the original equation?
So right now, do I know the slope of both answers? Yes. Slope is 3. Don't I also need the points that each one goes through so I can figure out both lines? And I don't know either point yet, but I do know one of them has a 0, and now I just got to figure out the point. And I know the other one's got a 2, and then I got to figure out the point. Once I've got those, I can figure out this line, I can figure out that line. The really nice thing about this one is, whatever that number is, this is the what? Y-intercept. So I'll know what B is. That kicks ass. This one, not so much. So if I know, how do you figure out this point then? If I know I'm at x equals 0, how do I figure out this point? Plug it in where? Let me see, where'd it go? Line this up a bit. Which problem was this? 63, okay. Something like that, okay. So this is the derivative. I'm not going to plug it in there, of course, because I already know that makes it 0. I want to know what the output is. I'm going to plug it into the original function. I like it. So visually, it makes sense. There could be 2 places that have the same slope. And really then, to figure out the tangent line, you got to figure out what points those go through. Okay. That is a more challenging problem, I agree. But you just have to start picking out what's immediately most important. And the very first thing that was most important in that problem was they give us 2 ways to figure out the slope, so of course they have to be equal to each other. Yeah?
You said plug it into the derivative or into the tangent?
I want to know where the function is. I already know the slope is 3. I want to know where the function is, so I want to plug it into the original function. Yeah? Okay.
It says find the equations, right? So the equations, and then solve
What 2 things do I need to find the equation of a line?
your 2 points.
You need a point and the slope. Slope we knew from the beginning. Slope is 3.
We just figured out a way to get the point for this line, and we figured out a way to get a point for that line.
And you plug it into, this.
Oh, I see what yeah, y minus y1. This first one you don't have to do that, because that's gonna be v, right? Because that's the y-intercept. Would it still work if you did y minus y1? Of course it would. Because that's a more general equation.
Would you use like the so-called quotient, the quotient thing, the f of x plus h?
No, we're past that. This is a chapter 3 question. Yeah, okay.
No, but the equation would be, once you find that point, it's y minus.
Yes, totally,
y
yeah.
value.
Y minus
equals
y1 equals m times
3.
x minus x1.
Okay.
And what I'm just saying is this one you can use mx plus b directly, because that'll be b.
Oh, gotcha.
Yeah, okay. So again, students don't like that kind of problem because it's multi-step. But you have to latch on to what makes immediate sense. I would hope we all are cool. They tell me it's parallel to that line, so you can say, okay, I can find the slope from that. Yeah.
So does it matter which function you put it into, or do you use the 3x minus y?
So in this problem, I have a function, and I'm sorry, this just never mentioned it. I have a function, and I have a derivative of the function, correct? If I want to know where the function is, am I going to use the derivative or the function?
I'm just wondering, because you have the 3x minus y there as well.
What is the only thing this does for me in this whole problem? I only have to use it once to do what? Because our answers are parallel to that dude. So our answers have to have the same slope as that dude. So once I use him to get the slope, I can throw him away. And again, these are not life lessons. These are. Does that make sense? So this is there just for, I only care about it for a moment, because the only thing I can get from this is the slope. And we got it, forget about it. Okay, maybe. Is there a function where there's an infinite number of points that have the same slope? Huh? A line, good. Is there a curve that has an infinite number of places that have the same slope? So a line, is everybody with me? A line has, every point on the line has the same slope, yes? So that's the trivial solution to that question. Can somebody give me a function where it has an infinite number of places that have the same slope? Yes! Sine and cosine. So sine goes like this forever, yes? So whatever the slope is here, it's the same as what it is here, is the same as what it is, forever. Okay. Maybe. Okay. So a cubic, a fourth, any higher degree polynomial could turn and then end up having the same slope at several places. Okay. I like it. Anything else from homework real quick? Yes?
2.8, can you go over how to do 2 and then 4 through 7? I just.
Let me see, 2. Oh, so this one's saying use the graph to estimate where the value of each derivative. Okay. So now they want you to estimate what f prime and negative is. Let's do one example and I'll show you how this works. So I want to figure out, and this is my book, so I'm going to write it. F prime at -3. So that's right here. I want to figure out this slope, yes? The derivative at -3, is that cool? Mm-hmm. So let's see, -3, 1, 2, 3. So I'm right there. So I want to figure out this slope, yes? So what I can do for myself is I can estimate, okay, it seems to go through that point, and it seems to maybe go through that point, right? Mm-hmm. I can kind of estimate 2 points it goes through and then just figure out the slope. I'm just estimating this, so it doesn't have to be perfect. You guys kind of with me? Okay. So any point they ask you to do that, you can kind of like, I don't know if you want to write your book, but this is mine, so who cares? You pick whatever point they ask, so at 0, so I want to know at 0, what's the slope through there? So you kind of draw the line, and you look to see, does it intersect any nice place so I can get that point easy? Does that make sense? So if I draw this line, and this is a good place to get like it looks to go through that point, and it looks to go through that point. So then I can do rise and run, I can get the slope. You guys see that?
Yeah.
So when they give you a grid like that, and it's relatively nice slopes, it's easy to estimate it. You just kind of draw the line in, and then you see what points does that go through. We're just trying to estimate it, so it doesn't have to be perfect, right? Is everybody with me? That kind of is like the idea of a secant line estimating a tangent. Yeah, okay. Okay.
Yeah.
I saw one other hand. Yeah.
Could you explain 61 on 243, page 103?
Is that the, yeah, I want to go over the squeeze theorem. I don't know if that's, oh, this dude. Okay. This dude is so, there's a really long, drawn out way to do this. Oh shit, let me erase this stuff. So, for most values of this, what immediately do you notice about this limit? What do you notice about that limit at 1? What's bottom 0? Wouldn't that be infinity for most things? If the bottom is 0, isn't the answer going to be some kind of infinity almost always? What is the one time it won't be? When the top is also 0, yes? Then it might not be infinity, because then maybe you can factor blah, blah, blah. So let me see if you guys really get this. This is so awesome. There's a long-ass way to do this problem that I saw some of you guys copying from the solution manual, so be careful. There's a really quick way to do this. If I have a limit where the bottom is 0, the only way the answer won't be some kind of infinity is if the top also goes to 0. If the top is supposed to go to 0, what does this have to go to? Done. If this goes to 8, doesn't the top go to 0 also? You guys are all with me.
Well, it makes sense, but I don't see how that has to do anything with the problem.
What did we just say? If the bottom goes to 0, so does the top. What's the only way to make the top go to 0? The limit of f has to be what? 8. Isn't that the question? Didn't we just determine the limit of f is 8? Done. So the idea that indeterminate form means I haven't determined it yet. I have to factor it or use some conjugate, yes? If the bottom is 0 and the top isn't, that is determinate. It's some kind of infinity. I will be done once I figure out the sign. Are you guys with me? I want this to make nothing but sense. If the bottom is freaking 0, almost all the time it's going to be an answer of some kind of infinity, unless the top is also 0. You guys kind of with me?
Right.
Say again?
Maximum equals 10.
Okay. This number doesn't mean shit, right? I need you to be with me. So the only way this limit is not infinity is if the limit of this is 8. That's the only way it's not going to be infinity. So what you need then, let me see. Let me do an example. Yes?
So you said the bottom would be infinity, but why wouldn't it be
Oh, all right.
like,
The bottom is going to be 0, yes?
Right.
Okay, okay. So, for example, let me show you an old example real quick. Okay, is the bottom of this one going to go to 0?
yes.
Do we all know by sight that the answer will not be infinity?
Yes.
Okay, why?
Zero.
Because it also goes to 0 on the top. So it's in indeterminate form, which means I can't say the answer is infinity. I can't tell yet. So in this case, what would I do?
Factor the top.
Factor the top, these cancel, I get an answer. I get 6, right? Because it'd be x plus 3, x minus 3. So the x minus 3 should cancel, is that cool? Okay, we've done enough of those. If I put anything else on the top, if I put x squared minus 8, is that in indeterminate form?
No.
What form will it be in?
Number over 0.
1 over 0 to be precise, right? You guys got it with me? So that's gonna be some kind of infinity. The top is gonna be positive, so that's gonna be, well, I gotta be a little careful because this actually goes to 3. I'd have to say from above or something. That would be a question about what kind of infinity is the answer gonna be.
Yeah.
Yes? So the only way that I can counteract the fact that the bottom goes to 0 is if the top also goes to 0. Okay, so watch this, watch. So if I have this, let me see from the left, okay. I'm sorry, from above, from the right. What's that answer?
1 over 0.
What's the answer? That's the form of the answer. 1 over 0 cannot be the answer because I can't divide by 0.
What?
Positive infinity.
How do you know?
Because I'm going from the right. So numbers I plug in are bigger than 3, so the bottom is always positive. Is that cool? I'm approaching 3 from the right. So I'm plugging numbers in that are bigger than 3. Okay, look at me, look. I'm plugging numbers in. I'm plugging numbers in that are bigger than 3. So when I subtract 3, isn't the answer positive? 3.1, 3.01, yeah, okay. So this would be positive infinity. If I put on the top, so the reason this goes to infinity is the bottom goes to 0, but the top doesn't. So the top can't counteract that the bottom is getting small. If I put on top that, this is kind of an extreme example, but now does the top get small as the bottom gets small? So they're lockstep with each other, which is one really good reason why the answer here would be, does anyone know what the answer there is? No? What do these do?
Oh, it cancels.
They cancel. So the answer is 1. They're perfect lockstep with each other. The bottom gets really small, but so does the top. If the top is stuck at 1 and the bottom's getting really, really small, that's going to infinity. The 1 doesn't change. It can't keep up with the bottom getting really small. Are you guys, does that make sense? So the only way the limit of a ratio when the bottom goes to 0 could be anything other than infinity is if the top also goes to 0. You guys kind of with me? So does it matter that the answer to this limit in this problem is 10? No, that doesn't matter. They could have put any frickin' number they wanted here. What's important is this is not infinity. If this is not infinity, the top must also go to 0. If the top did not go to 0, shouldn't this limit be some kind of infinity? Are you guys with me? If the top went to 7, this would be 7 over stupid small, should get stupid big. Are you guys with me? So I appreciate that you're concerned about the 10, but the only thing the 10 is doing is, hey, I'm not infinity. They could have put a 7 there, they could have put a 3 there. You guys kind of with me? Yes? Okay. This one is definitely a freakier one. Right? So let me, all right. Which one of these problems do I have to do more work for? Let me see. That problem, and I'll write another problem down here. All right, that problem or this problem? One of them I don't have to do any work, really. I can just kind of tell. And the other one I'm going to have to do some work.
Bottom.
Yeah, which one do I have more work to do? Which one can I not get the answer immediately?
The top.
Why?
Because 0 over 0.
It's 0 over 0, yes? Indeterminate form, I have more work to do. That means the limit of this could be something other than infinity. Because you could cancel that x minus 2. What's the only reason this seems like it could be infinity is because the stupid x minus 2 is on the bottom, right? Well, if it cancels, it could be 10. The limit could be whatever, yes? This one. Now again, let me do this. Okay. just because. I don't wanna worry about the above or below. Is this indeterminate form?
No.
What is it? The bottom is 0, yes?
Yes.
But the top is? It's -1, right? How did I get that? Just plug a 2 in. If I plug a 2 in, I get 8 minus 10 is -2 plus 1 is -1. You guys with me? Is that indeterminate? No. So I should be able to determine the answer immediately. It's gonna be some kind of infinity because this thing did not cancel. So looking back at this problem again, and again, this is a more conceptual problem, I understand. It's not supposed to be an immediate thing. You're not supposed to know, oh yeah, we did a bunch of these together, me and Jeff. No, this can't be that. This is its own little, hey, this is a weird little thing, but it's coming off the idea. The only way this could possibly have a chance to be not infinity is if it's 0 over 0. So did the problem say, tell me exactly what f of x is so it comes out to be 10? No, it just said what's the limit of the function. The limit's gotta be 8. If the limit of the function's 8, what form is this in? If the limit of the function's 8, what form is this in? Indeterminate, 0 over 0, kick ass. Okay. Now, it would be a much harder problem than then say, okay, what function makes that limit exactly 10? I think that's what some of you guys thought it said. It doesn't say that shit. That would be harder. How many functions have a limit of 8? At 1. Take a guess. Infinite number, yes. There's an infinite number of functions I can make up that have a limit at 8. So which one of them makes this limit 10? I don't care. The question doesn't ask me for that. I feel like some of you guys thought it asked for that. No. So the only way that the limit of a function where the bottom is 0 at that point could be anything other than infinity is if it's 0 over 0. Then there could be something that could cancel. Okay, is that better? This is a very conceptual question. There is some weird ass work you could do, but I see no reason to, because it's just a conceptual question. Okay.
So would the domain be the answer to the limit? Because it's asking for the domain though.
No, where? Number 61?
Yeah, 61. It's set up in the instructions. It says limit of x to a r x equals ra for every number a in the domain of R.
What? Wait. Where are we looking? Wait a minute.
Oh shoot.
We're looking at, oh, you're looking at 60.
Oh.
Oh, I'm looking at 61, yeah.
Okay. I thought that was an instruction for.
No, that's this number 60.
Okay, cool.
Yeah.
Thank God.
Let number 60 worry about number 60. We're gonna worry about this guy. Yeah. Okay. So let me ask you this real quick. Can you guys come up with, if I have this so far, if I'm trying to create a problem for you guys, and I have this so far, can you guys, don't say anything. There's a really simple answer, but let me see if anybody can be more creative. Can somebody put something up here? Think about this for a minute. What would you put here so the answer is not some kind of infinity? Don't say anything. So I'm going to say x minus 2 is my answer. Nah. Now you come up with another answer. Right? I want to know, what could I put here so the answer is not just positive or negative infinity? So I got one solution. I got one answer. You ready?
X minus 3.
I already took that one. You can't take that one. It's mine. Somebody said you could put x squared minus 4 up there. Would that work? Why would that work? Two reasons.
X plus 2, x minus 2.
It factors and cancels that, and also it's 0 at 2. So this would be 0 over 0, correct? So then, do you understand now, all you need is a function that is 0 when the input's 2. How many functions do that? Infinite number. Can somebody else give me another function? Is everybody with me on this? If this is in the form 0 over 0, the answer could be something other than positive infinity or negative infinity. So one answer would be this. What's another function I could put? Let me just put f of x here. What's that? So one answer is this. What's another answer?
X squared plus 4.
Say again?
Negative x squared plus
Alright, 4 minus x squared. Sure. So any constant multiple of this would work, yes? I can say 2x squared minus 8. Say 11x squared minus 4. That'll all work because it'll still factor the same way. It's still 0 at 2, yes? Let me do this one. X cubed minus 8. Is that cool? That's like the one I gave you on the quiz that everybody really enjoyed. Anyway, do you guys see how that could be a problem? Come up with as many functions that would make this limit possibly not infinity. That is a conceptual problem related to that one in the homework. Okay, that's the importance of indeterminate form. Because maybe the thing that makes it look like it should be infinity, maybe if I put any of these in there, won't it cancel? Then it won't be infinity. Can't like it. Hey, Mikey. Okay, enough of that. Whew. That probably went off on a tangent, but it's really good. There's some. All right, this is, bless you, this is not an easy problem. This is not a problem we do a billion examples of, and you're going to see a ton of those kind of problems. And it's unfortunate, I really feel bad, and I'm sorry that if you haven't gotten practice at that before now, but it shouldn't be, here's 80 problems, and the homework is going to look just like those. That's not what math should be. Math should be, here's a concept, here's problems that use a concept, I'm going to give you other problems that use a concept. Okay, and I know that doesn't make anybody feel good, but I'm sorry, but that the concept was the most important, yeah.
On 2.5, there's a bunch of theorems. Are we supposed to know all those?
2.5?
2.5? Yeah.
So I pointed out the most important one.
Okay.
So first off, this is just the definition of continuity, so we talked about this. And the most important, then this is from the left, from the right, that kind of stuff?
Yeah.
Okay, so those are important.
So we're gonna need to know these for the test.
Yeah. But things like this, I'm not even gonna make that big of a deal of, because if I have two functions that are continuous, of course when I add them, they're still continuous, right? That's all this one says. Okay. The most important theorem, I think, in there is this one. These are functions that I don't have to do any work for, I just know they're continuous on their domain. So for example, can somebody tell me, where is this function continuous? Everywhere except -2. Good. It's continuous, it's a rational function, so it's continuous everywhere on its domain. So where's it continuous? Everywhere except -2. Because -2 is not in its domain. 11. Kick ass. Okay. Alright, so let's do this. I'm gonna push us into finishing up what I need to in chapter 3, and then the rest of class will be devoted to review. I managed to get a decent chunk of the problems in an answer key. The rest we'll do together in class. So last time we had this worksheet. Anybody need this worksheet? Everybody else has the... Huh? Yeah. Yeah.
Alright. These units learn how to manage.
So what I want with you guys is kind of review a little bit. I'm going to talk about this one a bit later. I just kind of stuck this on there just to have it to point at. So the idea that we developed here is a shortcut because we noticed that no matter what power I put on the x, when I do the limit definition, the same thing happens every time. So who remembers this shortcut?
X, I mean, n over x.
Yeah, the power comes down
So n.
And then you subtract 1.
and it goes down by 1. So let me do one a little bit freakier. By the way, do you hear what I doesn't matter what the power is? Nope. So what about this dude?
Negative 1/4 x.
It's good. So the negative 1/4 comes down.
Minus 5/4.
Yeah. So a lot of us have some trouble with fractions. Here's a really kick-ass rule about fractions. When I'm subtracting one, this kicks so much ass. What am I supposed to do here? I'm supposed to make that go down by 1, correct? So it comes down, and then I subtract 1 from it. So let me just show you. This is kind of silly, but if I take negative 1/4 minus 1, don't I need an LCD? Wouldn't this just always become whatever that number is? I would multiply top and bottom by whatever the hell that number is. So don't I end up just doing negative 1 minus 4? Can't I just do negative 1 minus 4? So whenever you have a derivative of a problem that has a fractional power, when you want to figure out what goes here, you take the top negative 1 minus the bottom minus 4. So negative 1 minus 4 is negative 5, and you put it back over the bottom. That's silly. So what if I had h of x equals, what do you got, Jeff? X to the negative 12/23. First step is easy, yeah? What's the first step?
Subtract, negative 12.
Take the negative 12/23 down.
X.
Negative 12 minus 23.
Negative 35.
Negative 35 over 23. Done. Yes?
Just for sanity's sake, in engineering or other scientific applications in math, do you find these kind of numbers?
Oh, hell
Also,
yeah.
Like Gauss or like Coulomb's law and the gravitational law, there are square fields and they're like weird numbers. Alright. Are you just
So 2 answers to that. I don't care is one answer. But secondly, hell yeah. Hell yeah. So even if you didn't, you still need it for this class. I don't care. But hell yes, you see, sure, you have the inverse square law. Great. But that's not the be all end all. You have other things. So you definitely will see radicals all over the place. Yeah, okay.
Oh, as I say that, just to remind you guys, 2 things. What if I already had something here? That's not too bad, right? What's the derivative of this?
21x squared.
Good. Whatever's already there just multiplies by whatever's coming down. In fact, we already did that. When we did this problem, what was there? 1. So of course it multiplies by 10. So of course we just keep doing the same thing. So what if, what was the other thing I was going to, oh yeah. What if I had like a 4/5 x to the 7/15?
You multiply those two and subtract from 7/15.
Yeah, so what I would do is I do 4/5 times 7/15. So bring the 7/15s down. Anybody know how do we get that power?
Subtract 1.
7 minus 15? Negative 8 over 15. Cool. And then this you just multiply across because nothing cancels. Is that all right? Okay. Yes. Say again, sir? All right. So the rule is the power comes down, correct? So that's what I did here. Then I subtract 1 from this. And the shortcut I just explained is if you just do the top minus the bottom and then put it back over the bottom, you'll always get what you would get if you subtracted 1. It's just a little shortcut.
I think his question is about the derivation of the power rule. The Pascal's triangle, the limit.
Is that your question? No. Okay. It was about this specific problem, yes?
Yeah.
Okay. Is that better? The power comes down, multiplies by whatever's there already, and then it goes down by 1.
But it was positive 7, so why is it? So you times it by -1?
Definitely not.
So then why is it -8?
So I'm subtracting 1 from it. So is 7/15 bigger or smaller than 1?
Smaller.
So when I subtract 1 from it, the answer should be negative. Yes?
Okay.
So a shortcut, instead of getting LCD and doing all that, the shortcut is 7 minus 15 is -8 and put it back over 15. That is a shortcut. If I do it the long ass way,
I have to multiply top and bottom of this by 15. Don't I get 7 minus 15?
Yeah.
Negative 8 over 15. So I'm just showing a shortcut. Yeah.
Okay.
You don't have to use a shortcut ever. Okay.
So then what is the 4/5? You just leave it as 4/5?
No. So now you do 28 over 75. Right, you just multiply those together.
Okay.
Okay. So what I want you guys to do, try these out. Oh, that's what I was gonna do, that's right. Notice the last one. This rule only works if it's in this form, the x to the n. So you need to rewrite this so it's in that form. Let's go ahead and try this first row out real quick. Some of these should be pretty quick. We'll see. You can kind of compare and contrast with people near you if you want to.
Yeah, because if you were to do it in terms of square roots, this ends up being 1/2 because this is to the power of 1 and to the root of 2, right? So if the 1 from the inside goes on top and the 2 from the outside goes on the bottom, that's just how I remember it. So that means the 9 has to go on top and the 7 has to go on the bottom. Why did you get 1? Nothing you don't really necessarily
Getting close to
Interview nice.
I got 9 7 times 2 2 7. Where did I
Yeah, you can do that, but you can do 2 over minus 3 over 3.
Where'd you break it up?
No. So, yeah. And that's what you'll get.
No, so the thing is,
Negative 1 over 3.
Yeah.
Minus 7. Find the tangent line to f of x equals 3.
Well, it'd be nice. Yep. That's how I rewrite it, and then you can take the derivative. So root notation sucks. What's the derivative of thing? What's the slope of negative 9? Flat, 0. So the slope of the derivative of any.
I'm just gonna set that there.
That's this. All right, let me see.
We'll see. That's how I remember it, and
It's because look at what happened.
Yeah.
exactly. Look at what happened. Because that's
So
how
the one
you
comes down, it
rewrite
goes
x
down by
into
one,
a-
so it just becomes
That's how you
2.
rewrite that into a.
So then it'd be x to the 0.
That's like technically.
Or a better way to look at it is what's the slope of the
You
2?
just have to remember how to write that shit into this one. And that's why I always do that example.
Was x to the 0 power and derivative of any constant.
That's why a square cancels out this one because the 2, like if it was this, that's why those cancel. Because if you were to rewrite that into an exponent, it's just going to be 2 over 2, and that's just 1. So it's just going to be x over 1, but it's just x. You see what I'm saying? See what I'm saying? You got a revolution of 2.
I like it. All right, guys, let's see. First few
5 of
Need to be
5x
easy.
to the
5x to the
4th,
fourth.
negative 33x to the 10th.
Yeah. So the 11 comes down, multiplies by whatever's there already. Power goes down by 1. So we got whole numbers, that's nice. This one is just using like this rule.
16x to the 7th.
So the slope of the whole thing is the slope of each piece, right? So the derivative operation is known as a linear operation because doesn't it look like it distributes? Now I'm not multiplying, so it don't distribute. But what that means is if I want to know the derivative of the addition of a bunch of stuff, I could just add, subtract all the derivatives of each piece. It looks as if it's distributed. Okay. So the derivative of this becomes just just 4 different problems, right? What's the first do?
16x to the 7th minus.
Good. So the 8 comes down,
Yep.
and it goes down by 1.
Yep.
3 comes down, 9
x squared.
goes down by 1.
Plus 2.
Now here's where people really kind of talk themselves in this weird corner. So you can look at this several different ways. The slope of 2x minus 9 is 2. I'm done. The derivative of 2x is 2 because the 1 comes down and then it goes to 0, so I have no x's left. If you want to look at it the same way here, how many x's do I have in this expression? So I have x to the 0. So the 0 comes down, makes it 0. So the derivative of any constant is 0, because every constant, if I graphed it, would have a 0 slope. And derivative is slope. Now I think this said 5x to the negative 3.
Yeah.
Here's another place where people make really, really silly mistakes. What's the answer here?
Negative 15
It's good. It comes down.
to the negative 4th.
Can anybody understand if somebody put a negative 2 there?
Yeah.
You can understand the mistake they made, but they made it one bigger. So you got to make it smaller, so it's got to get more negative. Yeah. Okay, I like it. Yes. So you could make this become this. It really depends on what you're doing next. The form it should be in depends on which form will help me do what I got to do next. What do I have to do next? Nothing. I'm done. So would I accept this answer? Oh, hell yeah. But do you have to make it look like this? Oh, hell no. Okay, I like it. This guy,
2/3 x to the negative 1/3.
yeah, that one's not too bad. You might not need my little rule just to subtract 1 from 2/3. Okay. And then this last dude, okay. Radical notation sucks for so many reasons, but this is a big reason why. I don't have a rule for this dumb thing. If I rewrite it, I can make it follow the rule that we've already created. Square root, what's it do to something? Cuts it in. So that's why. It cuts it in half multiplicatively, right? If I just said what's half of 9, you should say 4.5. If I said what's half of 9 multiplicatively, you would say 3.
Yeah.
Because 3 times 3 is, half of it would be 3. So a square root would be a 1/2 power. So the root is on the bottom like plants, right? So what's going to be on the bottom of the fraction that I rewrite this as?
7. So it's 9/7.
Yes. The root is 7. So it goes on the bottom like most plants. Where my botanists at, don't come at me with, well, tubers are actually, no, get away. Most plants, the roots are on the bottom. Powers are powerful. Yeah, I'm a fellow geek, so I can make fun of other geeks. Powers are powerful, they go up on top. You guys kind of with it? If you really want to look at this, this says x to the 9th to the 1/7. But then what do I do with the powers? Well, so then I get 9/7, so might as well go straight to there. The root in the bottom, the power on the top. Now, how do I do this guy's derivative?
Bring the
you're
9 to
gonna
the
add 9/7
sevens.
to the front,
9/7 comes down,
and then you're gonna subtract by 7/7, so you're gonna be left with 2 7.
2 7s, because 9 minus 7 is 2. Yes?
I have a question out of curiosity. If we were to do the final exam, would we be able to use like derivatives and stuff like that instead of like the step-by-step stuff that you make?
You would
us do in
only,
chapter
on the
2?
final exam, you would only use the limit definition if I actually say use the limit definition.
Okay,
If you know anything about me, you know I'm probably going to say that.
okay.
On one problem. So everything we're doing right now is trying to get away from that limit definition, but we're still going to have to use it to develop rules. So I use the limit definition of derivative to develop this shortcut rule, right?
Right,
Okay.
okay.
Now we've got another tool in our pocket. If I need the slope of a function for any reason, I know how to get it quickly. If it's, in the form x to the n. So what piece of that function is not in that form at the moment? What piece of the function is not x to a power? The second piece. How do I rewrite that?
X to the
Yeah, 2x negative 1.
Yeah, so it'll be 3x to the 4th minus 2x to the negative 1. If I take the derivative, what is that doing to help me answer the question?
Find the slope.
It's going to help me find the slope. Kick-ass. Derivative is slope. So the derivative is a function that tells me the slope at any point I want.
Which is 12x cubed.
So what's f prime now?
12x cubed
Good, the 4 comes down,
minus.
power goes down by 1.
2x
The negative 1 comes down,
negative 2.
makes it plus 2x to the
Negative 2.
negative 2. Yes. Say again. Do you agree there's a 2 there? Is the question from here to here?
Yeah.
So if I bring that x up, it becomes x to the negative 1. And the 2 is just sitting there. Hell no, I'm not allowed to take the middle of a problem and reciprocate it, because then that would be a completely different function. I am saying x to the negative 1 is the same as 1 over x. What's a negative power do?
Oh, it's inverse.
No. Negative power flips. Negative power flips. Reciprocates. Right? Okay. Yeah.
Is the word inverse word as well?
Sort of, but it's not specific enough, because the inverse of a function is not the same thing as reciprocal. Multiplicative inverse is reciprocal, additive inverse is opposite sign. Yes?
So, is the tangent line what is it called? The f prime?
No? What does this help me get that I need for the tangent line? Slope.
Could you put x into that equation?
What x?
The point.
Sure. What am I going to plug into this equation? 2. Good, because I wanted the slope at 2, correct? If I know the slope at this point, and I know this point, I can get the equation of the line easy.
So 47.
No. So I'm going to use this space down here just because I'll do another sheet of paper. So f prime at 2. This will be my slope, yes? So I can put that there if I want to. I'm figuring out what m is. So when you plug a 2 in, what do you get? Oops.
That 96.1.
Yeah! Okay, that sounds about right. 12 times 8 is 96, plus 2 fourths, plus 1/2, so I get 96 and a half. Is that all right? Just plug it in on calculator if you want to. So that is my slope, and I know my point. So can I get my equation for the line? Yes. So, algebra, calculus, I don't care what class you're in. If I say find the equation of a line, in this case tangent line, I need 2 things, slope, point. That's what I need. So now I know my point, so it could be, I could do y minus the y piece. equals m times x minus the x piece. Right? I could do it that way, or you could solve for b if you want to do it that way. You get y minus 47 equals minus, what is that? 193. Minus 146. Is that right? Just add the 47 over, is that okay? Now, two things. If I ever do something you're not sure what I did, just ask me, not a big deal. At the same time, I'm also going to go through algebra a little bit quickly. So you need to slow me down if I do something you don't understand what I did. But I just distributed and then I added. Is that a pretty line?
No.
Maybe not. We'd rather have 2x minus 1, but we're done, so we almost don't care what it looks like. We're done. Yeah, I like it. Yes?
Where'd the 193 come from again?
Oh, distribute. So I just doubled 96.5.
Oh.
Yeah. Okay. All right. So the last problem, number 3. This is a major kind of problem. Let me show you an example. If this is my profit function, right? That's my profit function. Where do I want to be?
At the maximum.
I want to be here. Yeah? If I can't get exactly there, then I want to be somewhere close, yeah? So what's a really good thing to figure out if I know my profit function? A really good thing to figure out is where the hell is that point? What's the tangent line at that point? What's the slope of it? Sorry. 0. So we're going to see a bunch of problems where it's going to say find the max or min, which really for us means find where the horizontal tangent line has a slope of 0. Find out where it goes flat, because that would mean it's a turning point. Yes?
Is it the same thing as looking for the local max and min on your
Totally.
calculator?
Sort of. Does the calculator do that? No, it does something different. We're going to actually learn what it does for some things later this semester. No. So looking at this last problem, when I say where the tangent line would be horizontal, you interpret that to mean slope is 0. I want to know where is the slope 0. And all we know is what the function is. So how do I start this problem? Yeah, find the derivative. If I would have said find all the places where the function is 0, I would have set this thing equal to 0. I want to know all the places where the tangent line would be horizontal, meaning the slope is 0. So I got to first figure out what the hell is the slope. So what is the slope?
3x squared.
Good, 3x squared, 12x minus 63. You're maybe not at the point where that's quick, but that rule kicks so much ass. The only place it gets weird is when you have fractional powers. And I've already shown you some shortcuts with that. So now what do I want to do with this? No, I don't want to plug 0 in. I want the slope to be 0, and this whole thing represents slope. I don't want to know the slope at 0. I want to know where is the slope 0. You guys with me? So this is a beautiful general thing you got to be careful about is where the hell do you plug that value in? Be sure you know what it represents. This is the slope, and I want the slope to be 0. So if I solve this, I'll solve for x. That'll be the locations where the derivative is 0, where the tangent line could be horizontal. And it's a cubic, so it probably looks something like this. So there's probably 2 places, right, where it's horizontal. So of course, what's the first, what makes this easier? Is anybody concerned about the big ass numbers? Because I can immediately chop them down, right? Divide by 3. So then I get x squared plus 4x minus 21. And I want that to be 0, and that's easy to factor. Please, dear God, don't just go to quadratic formula all the time. You need practice with factoring, and factoring is much quicker, right? When it works. How do you factor this?
X plus 7, x minus 3.
Good? So where are the two x locations?
-7 and 3.
Good. Now if I would have said find the points where it's, then you would have to plug it in to get a full point, yes? But I just said find the locations. So at x equal -7 and at x equal 3, it might have a max or a min. Yes?
I have a stupid question, but how come you don't divide 0 by 3 if you're dividing everything by 3?
I did. Right there. What's 0 divided by
Oh, yeah.
3? 0, yeah. So when you have a 0 on that side, it kicks ass because it just eats whatever the hell you divide
Yeah.
by. Oh, bro.
Is the tangent just like a horizontal line when you plug it into the first equation?
So if I plug -7 in, I'm going to figure out the point that it is, right? And then I could figure out the line if I wanted to. So that's a little bit beyond what this wanted us to do, but that'd be the next step I could do. Is that what your question was?
Yeah.
So if I plug -7 into the function, I'll see. So for example, let's do this real quick. I can do that real quick with my calculator. Here's a really smart thing to do in general. Even if I don't ask you to use your calculator, you can still plug stuff into your calculator and make sure it makes sense. So if I put in here x cubed, where'd it go? Plus 6x squared minus 63x plus 8. And I try to graph this thing. Let's see if it shows up here. No. So let me give you a little hint. You ready? Okay. I don't know, that's not the complete graph.
Because there's no bottom, we can't see it.
That looks like a parabola. What should it look like? It should look like that, right? Okay. So one thing you could do is if you go, let's see, well, how can I say this? I want to zoom out a bit. So there's actually a thing called zoom out. It's not a bad thing to try to do. That's a little better. Do you see how I want to look up much further and down further? So what I'm going to do is I'm going to go to window. I'm going to look down more, and I'm going to look up more. Almost. I can see this dude, right?
Yeah.
So I'm going to go back to window. I'm going to do a couple things on window. I'm going to make my X not go out as far because I don't need it to. I'm going to look down a little bit more, and I'm going to look up a decent amount more. Let's see if I got it. Almost. So I just got to look up a little more. But right now, this bottom here, do you guys know how to find the minimum? On your calculator, do you know how to find the minimum?
Second calc.
Second calc minimum. Crazy. So I tell it a left bound. So I hit enter left of the answer, I hit enter right of the answer, and then I hit the enter right on the answer. What is that trying to say? This is the calculator not being able to resolve it well. What do you think it's trying to say? 3. Was that one of our answers?
Mm-hmm.
Hey, all right. And I bet you anything this other one is going to be -7, because that was our other answer. A lot. Okay. Real quick. You guys now know one more symbol. What other symbol is brand new? What other symbol is calculus that we know?
Y over dx.
Number 6. So let's see what that does. You ready? I picked that one. You ready? I'm going to put in there 3. And look what it tells me. The derivative. What's it trying to say there? Do you guys know what that means?
0.
That means like 1 times 10 to the -6, which is it saying 0, really. It can't. And again, it's poor little calculator. It does this little algorithm, and that's as close as it can get. Poor little dude. Okay, I like it. I'm not overly concerned if you can use your calculator. But if you can kind of check yourself as you go. Please, dear God, don't do the work on the calculator. It's bad. Okay. I want to do one thing, and I'm going to give us a break. I'm going to do a couple more things, and then we'll get into a review. Okay. Here's the one thing I want to do. We're going to work towards doing this. Can you imagine Alright, if I wanted to do this derivative, okay. We currently cannot do this derivative. Is it x to a power?
No.
So in order to do this derivative, I'd actually have to multiply this out 11 times. I have to write it. We're going to work our way towards a shortcut. You with me? The first step towards that shortcut is something called the product rule. The product rule by itself, at first, is going to be really lame. But the minute we learn some more derivative rules, it's going to become stupid powerful. Yes?
Can you zoom out real quick?
Sure.
Thanks.
So, what I'm saying is, if I have a function that is the product of two other functions, I want to see, is there a way to find the derivative of this in a shortcut way? I don't want to have to do it the longest way. So what we're going to do is, we're going to do it the longest way once, develop a rule, and then just use the rule. So here's what's going to become important in calculus. You all know the basic idea of derivative, what it means. We're now going to start to develop derivative rules. So we have to use the limit definition less and less and less. We can just use these rules, yes? So that should be big motivation to really know these rules so you don't have to use the limit definition. Holy crap. Can you imagine using the limit definition for this thing? 11th power. No thank you. Okay. All right. So if I just do the limit definition, let me see, h, it kind of sucks. Let me call this k, just so I don't have a multiple h's running around. You guys with me? So this will be k of x plus h minus k of x all over h. That is just the rule by itself, yeah? We're about to derive the rule. You're never going to have to do what we're about to do yourself. And it gets weird. I'm going to do something in the middle of it that you're going to say, how the hell would I ever know to do that? And you're not supposed to. Because you're learning for future math classes things you're allowed to do. So I'm going to do something in a minute that you're not even clear why you're allowed to do it. So here we go. I'm going to put in here what k of x plus h is. What is k of x plus h? Can anybody tell me what k of x plus h is?
F of x
Yeah?
times g of x.
No? What is k of x plus h?
F of x plus h.
F of x plus h times g of x plus h. Okay, I like it. Right? Minus, and k of x, of course, is just this. Is that cool? I already know what k of x is. It's this. K of x plus h is just plug in x plus h. You guys with me? Okay, I appreciate it if you're concerned about what the hell we're going to do next, but don't worry about that yet. What we're going to do next is something very creative. And this was done by people back in the day when they didn't even have TV or YouTube or whatever. So what they do, they had candle and they had paper and they had pencils. So they did this. So this is somebody with a lot of free time in their hands. They said, oh, I can do something with this. Can you guys see anything I can do with this? Yes?
How did you do the first part of the x plus h?
Oh, what is k of x? F of x times g of x. So what's k of 3? F of 3 times g of 3. So what's k of x plus h? F of x plus h times g of x. Just plug in x plus h in. Yeah. So I'm about, here's the step. Here comes the step. Sorry? I'm with you. So, like, some people would try to, I can't distribute the f because that's not how it works, right? Where's the square coming from? I don't know what the function is. Oh, I see you're trying to foil. But I don't know what the functions are, so I'm not even sure if I can distribute these things, yeah? Okay. So here's the part. I'm gonna add and subtract the same thing. which to me, whenever I do that kind of thing, I always think about Indiana Jones and the Raiders of the Lost Ark, right? The Raiders of the Lost Ark. You remember that scene where he's got the gold idol, and then he puts the bag of sand, yeah? So if he would have balanced his equation correctly, remember my Ken Stevens said, then the boulder would not have come down. But of course he didn't do it correctly, so the boulder comes down and says, you didn't do your math right, I'm gonna kill you. Okay. So here's how this works. Let me see if you guys can understand the reasoning on this. I'm gonna have this here. Holy shit, there we go. Leave that alone, and then I'm gonna subtract from this. What are you gonna subtract, Jeff? Yeah. Which means, do you see how that came out of nowhere?
Yes.
So I better at the same time add the damn thing, so that what did I just do? Nothing. So as long as I write that at the end, is what I just did legal?
Yes.
Can you start with 7 and then add 3 and subtract 3? Did you change 7? Nope. So I'm allowed, anywhere in the freaking universe, I'm allowed to add anything as long as I subtract it immediately. So on one level, you're like, good job, Jeff, you just did nothing. But let me split this into 2 problems, right? What can come out of these 2 things?
G of x plus h.
Yeah, they don't both have an f of x. They both have a g of x plus h, right? So I'm going to take g of x plus h out on the side here, and then what's left if I take a g of x plus h out? F of x plus h minus f of x over. Does that look familiar to anybody?
Yes.
Okay. Plus, so I'm splitting this up into 2 parts. You guys see that? I'm going to do the same thing over here. What can come out of these 2? Yes. So I'm going to take an f of x out. And what's left when I take an f of x out? G of x plus h minus g of x all over h. Does that look like something we know? So again, this is nothing I would expect you to be able to do yourself. The problems are not going to look like this. What we're doing right now is we're developing a rule that we can use. I want to remind you about that. We're going to do this a lot this semester. We're going to do proofs, and then we're going to get to somewhere, and we're just going to use the results. And I want to make it really clear when that's happening, because as a student, you're like, oh shit, am I going to have to do this myself? No. This is weird shit. Help me out. What's the symbol I can use for this? The limit of this, yeah. Say again, sorry. F prime, kick ass. Isn't that the limit definition of the derivative of f?
Mm-hmm.
And when h goes to 0, what does this become?
G prime.
No. Is there any? Why is this f prime? Because it's f of x plus h minus f of x over h. Yeah. When h goes to 0, what does this become? G of x plus f of x. Yes. And what happens, the limit h goes to 0 of this business, what symbol do I use for that? G prime. Isn't that G prime? Yes. G of x plus h minus G of x over h, the limit, that would be G prime. Is everybody sorted with me? This is called the product rule, because math people are really creative, and we went, here's a product. Here's a rule for product. Okay, so it's product rule. So let's do one concrete example, and then we'll take a break. Let me write the rule down by itself. As you guys try to capture that. It's not that important that you get this written down. I think they do this in the book, I can't remember. Okay. So if I have a function that's got the product of 2 functions, its derivative will be f prime times g plus f g prime. Now let me say this. This is kind of funny. Almost every rule we do this semester has what I'm about to say. Do you see how every function gets its own term? Do you see what I mean by that? Do you all agree that h is made up of the product of 2 functions? Doesn't each function get its own term?
That's going to carry through so many of the rules that we do. Why is this rule this way? Did we just pick it? No, you just watched me do the shit. It just is the way it is. Okay, I lock it. So let me start with a really, really silly example. What if h of x is x times x? Why is this a silly example?
Too many x's.
No. What is x times x? So on the side, real quick, on the side, if we happen to notice that x times x is x squared, what's the derivative?
2x.
Whatever the shit I do right now, the answer better be 2x, or we can throw this out entirely and we can go have an early summer. And you're all like, please let him make a mistake. Oh, now I feel, now I'm anxious. Okay. So if I want to do this derivative, here's the rule. This is the rule. First function derivative, leave the second alone, plus leave the first alone times the second function derivative. That's the rule, right? Each one gets a term. Derivative of the first times the second, plus the first times the derivative of the second. They each get their own turn having a derivative done. I would never want you to do this problem this way, by the way. I'm just showing you that this rule works, even with something we already know the answer to. So what is the derivative of x? 1. 1 times x? Holy shit. What's the derivative of x? 1. No, no, x. X. And what's x plus x?
2x.
Holy shit. All right. Same answer. So the more complicated these functions become, the more we're going to appreciate the fact that product rule exists. All right. Yes?
So that thing you wrote with all x's is the same thing as the f prime.
Yes. So what's f prime here? I'm sorry, what's f x and what's g x? So I just did f prime times g plus f times g prime. Okay. So we'll do more examples, but let's first take a break. Come back at 5 till. See how far I can actually make it. Yeah. What's up?
Oh, I've been meaning to ask you. How does your late homework policy go again? Because I was reading on your syllabus and it was just saying that, oh, it's just going to be considered late after the test. So how does that go? Like, I know you get less credit for it.
Yeah, it's not anything perfect. I don't have an exact rubric, but the later something is, the less it counts, and the more you turn in late, the less it counts. If you turn in like 2 sections the next class, I might not count it late at all. So it depends on how late it is and how much is late. Huh?
If it's like a week later, then you're like,
And that's the problem. Yeah.
okay.
Does it make sense?
Yeah.
Okay. All right, guys. Have you guys discovered? A few of you guys have been talking to me about some YouTube channels.
Yeah.
So, as a student in this class, I understand if it's been a while since you've taken something, if you just barely passed pre-calc, if it's been like several years since you took pre-calc, if somehow you never took pre-calc, you've got a lot to catch up on while you're doing calculus. I get that. This is why, for one reason, I'm going to start coming at like 8 in the morning. Because a decent number of people are here. I noticed I would come in at 8:30 and it would already be like 4 people. Okay, interesting. I can't stay too late after class, but if you ask me, I can stay later, right? If you want to come to my office, we can talk about some things. I've officially still got 52 students, even though they don't all show up necessarily. I've still got 52 students. That's quite a bit. So, got a lot of grading to do, but I desperately want everybody to do as well in this class as you can. And if prerequisite material is getting in the way, we have to address that before the calculus can make sense. So there's a lot of prerequisite material. So as we hit those things, feel free to ask me questions, feel free to go see the tutors, feel free to office hours, all that kind of stuff, right? So I've already given people some
handouts and worksheets from when I taught pre-calc. I can even give you handouts from when I teach algebra, whatever the hell the topic is. I've got crazy amounts of handouts and such. Yes? So I can help you with that. I am just one person though, so I can only like sit down with a person. So if there's any study groups, that's amazing, because then that makes use of time more efficient. I can help more people quicker. Anyway, okay. Also notice, if you didn't see earlier, the homework section 2.6, it should say every fifth one, 20 through 50. So, I think I'm gonna have to, oh, this sucks a lot. I'm gonna do one more, maybe two more things. I'm not gonna get quite as far as I wanted to. And then we're gonna somehow make up for that. Let me see, I wanna get up to, that's in there, yeah. Oh, good, that's in there. Okay, good, I can get up to, all right, so I'm gonna try to get to 3.3. I'm not gonna quite make it to 3.4, which kind of sucks, but it's okay. We'll be.
So it won't be on your test? 3-4?
No, so I'm gonna have to show you some more problems that won't be in the test, but we'll get there.
Okay.
So we've got the product rule. Let me do one more example of product rule. Yeah. So, do you guys see how you do not have to use product rule here? What could you do? Opposite of that. You could FOIL, you could multiply it out, yes? Do you want to? All right. You could. I'm going to say use product rule. Okay. Does everybody agree that this sucker has a function times another function? Yes. Okay. So how does the rule work?
F of time.
Good. So the first function gets a turn first.
Then g of x.
So I'm going to take the derivative of this times this plus. So the first function gets its turn. Then it sits there while the second function gets its turn. So what I try to get students to do, especially when things get more complicated, the mistake students make is because they're trying to do a rule and the derivatives at the same time. Have I done any derivatives yet? No. You could do derivatives, and you could do that for more simple functions. But when the functions get more complicated, dear God, you want to apply the rule first, which means you don't do any derivatives yet. Then you do derivatives on the next step, because you're not doing as much stuff in your head. So now I can, my whole entire world is just, what is the derivative of that?
2x plus 4.
2x plus 4, is that cool? Times this business. Plus, now what's the derivative of this?
3x plus 6x.
Careful.
I mean 3x squared.
3x squared, good, the 3 comes down, goes down to 2 plus
6x. I mean, yeah, 12x.
12x. And then the 11 goes to 0. I like it. Okay. And for this problem, you can just stop there, because otherwise it would be kind of crazy. Product rule by itself is not very powerful. We don't know enough derivatives of other functions yet. So eventually we're going to be able to do something like this. Is that all right? So you could multiply it out, but that's just gross, so I would just leave it here. Is that all right? Yeah, for this specific problem, yes. Because that would be the end. Okay. Yes. Cool. We're eventually going to be, in fact, very soon, we're going to be able to do a problem like this. Now, of course, we can't currently, does everybody agree with me that's a product?
Yes.
What are the two functions?
X and sin x.
X and sin x. We currently cannot do that unless you noticed I already did the work for sine on that handout, but we currently don't know the trig derivatives. Up here I had an alternate way. I could multiply this out, correct? Can I do this any other way? Can I multiply this out somehow? No, I have to use product rule. So once we start learning derivative rules for other functions, the product rule starts to become more powerful. Because without it, I couldn't do this worth shit, right? We don't officially know what sine's derivative is yet. Okay. Before I get to trig derivatives, what do you think comes right after product rule? Quotient rule. So we already know how to do, let me make sure you guys really get this. If I have a function that is the addition of several functions, we already know how to do its derivative. What's the derivative of this addition of functions?
3x squared.
Yeah, 3x squared.
Plus 8x.
And a difference of, if that was a minus instead, there would have just been a minus there. So addition and subtraction is easy. The product of two functions is not obvious. And one thing I want to do that I didn't do earlier, we just did that problem, x times x. If I erroneously thought that the derivative was just the derivative of one times the derivative of the other one, I would have thought the derivative of x squared is 1. Do you guys see that? The rule can't be just multiply the derivatives, because then I'd very obviously get the wrong answer. That's one thing. It doesn't prove it, but it makes it make more sense why one guy gets a turn and then the other guy gets a turn. I can't do them both at once. That's not how the rule works. Okay. So it kind of makes sense. Addition, subtraction, easy. I just do each piece, bam, bam, bam. Product, not as easy, but a relatively easy rule. F prime G plus G prime F, basically, is what it boils down to. So what about quotient? Quotient's going to be a little worse. And that should make sense.
It's a fraction.
So let me see if I can kind of truncate this a bit. Yeah, if I want to write it out, I get this business here, right? And don't use H again, Jeff. Use K. There we go. I'm not going to do this all the way out for the interest of time and because a very similar thing happens. But let's see. I might have to do more of it than I want to. But if I want to analyze this guy's derivative, at the moment, the only thing we have to use is limit definition. So what is k of x plus h? It would just be plugging x plus h in. Is that cool? So that's k of x plus h minus k of x all over h. Now, just for the interest, I'm not going to do a lot of this, but can you guys, what do you guys think when you see this kind of thing? What do you think I want to do here?
Get common denominator.
The common denominator. So let's see. So very quickly, what is this guy missing that this guy has?
H. Wait, the first one?
All right. Let me ask you this. You ready? This right here. I'm about to make a statement that might make you think I'm going to miss some meds this morning. I don't see an H in here anywhere. This guy does not have an H anywhere. It's got an X plus H in the middle, right? So what is the denominator of this guy? What's the denominator of this guy?
G of x plus h.
G of x plus h. What's the denominator of this guy?
G of x.
G of x. So what is this guy missing that this guy has? G of x. And what's he missing?
H.
G of x plus h. Again, there is no h, so this can't be missing an h. So real quick, does 8 have a 2 in it? Why? 8 is 4 times 2. Does 8 have a 3 in it? No. But 8 is 3 plus 5. So we know when I say in it, we know factor-wise. Yes? So is there an h in here? No. Because this is x plus h. Okay. So if I multiply this guy by g of x, and I multiply this guy by g of x plus h, they have the same denominator, yeah? Okay. So then I get f of x plus h times g of x minus f of x times g of x plus h. Now, a very good rule to understand. Do you see I'm dividing by this, right? Both of them? I'm also dividing by h. So I'm divided by h, I'm divided by g of x, and I'm divided by g of x plus h. You can just put all that shit together. And if you don't believe me, what does division by h mean? Divided by h, I multiply by 1 over h. So if I take this and I make it times 1 over h, doesn't an h just show up on the bottom with a should?
Yes.
Okay, so if I'm divided by multiple things, I can just list them all together. Because I'm dividing by all of those things. Okay. Do you see how I can do something very similar to what I did with the product rule? I can add and subtract the same thing. So let me just, for the interest of time, there is some cool kind of shit that happens here, but in the interest of time, and do you see on the bottom, when I let h go to 0, do you see I'm going to get a g squared?
Yes.
G of x times g of x? You guys see that?
Yes.
Okay, so what I'm going to end up with is if I have k of x equals f over g, the derivative is going to be f prime g minus f g prime all over g squared. The g squared part you can see right there. The minus you can see right here, right? You can see parts of it. Okay. Quotient rule kind of sucks. But do you see on the top how it's almost product rule, except there's a minus?
Yeah.
Which function is to a -1 power if I rewrote it? G. And if I have something to the -1, I take a derivative, doesn't a -1 come down?
Yes.
So you see how the part where the g is taking a derivative, see it's minus because g is on the bottom. There's a song for this, high d low minus low d high, blah 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 bullshit. I just remember top first. Whatever's on the top gets its derivative first. That's what I remember. But if you ask the tutors, they can tell you the high d low blah blah blah. Okay. Sorry, yes.
Why doesn't the h shut down the whole denominator, being going to 0?
So again, if you followed me earlier with this, see how the h made a prime here and a prime there? Same thing is going to happen here. I'm going to add, subtract a term. I'm going to separate them over h. That's where the primes come from. Okay, good question, but it gets looped in there. And that's where the primes come from. Okay. Quotient rule is a little more interesting. It's immediately powerful. So let's do a problem. If I have a function,
Bless you.
there's no way around this. There's no simplification I could do here that would keep me from having to do any quotient rule. There's a top function, there's a bottom function, I could do a quotient rule. To be really honest, once we get to 3-4, I'll show you what I used to do as a student, because I hated quotient rule when I was first learning it. Now I'm okay with it. So identify the top, identify the bottom, that's pretty easy to see. When I take the derivative, who gets the derivative first?
The top.
The top. Times the bottom. Minus, because you got a bottom, it's got a negative power, there's going to be a minus in there, not a plus. Leave the first guy alone. The bottom gets its own term. So see how that same idea of if you have multiple functions in there, they each get a term. That idea is going to show up in just about every rule we do. And then what do I do at the bottom?
Square it.
Square it. So it's top derivative times the bottom minus top times the bottom derivative divided by the bottom squared. And so now it's just a bunch of, simplification. This derivative is nice, yes? 2x. Minus x squared minus 1. What's the derivative of 2x plus 3? 2. Yeah, so one way to look at this is what's the slope of 2x plus 3? 2. And then this I'm going to leave like this. Pretty much never multiply it out, because at the end you might be able to cancel something. Can I cancel these right now?
Yes.
One of these? Yeah. Why can I not?
Oh, it's on the
Because division does not cancel part of a subtraction problem. Do you guys see that? Okay, so I cannot just kill one of these. Okay. So then I FOIL. Let me see if you guys are cool with this. I'll get 4x squared here, yes? Mm-hmm. Minus 2x squared. So I get 2x squared. Plus 6x. Minus negative 2. Oh, yeah, I call you with that. You could do it. Just distribute, do this, you'll get it together. All over this business. Does the top factor?
Yes. Well,
I can take a 2 out, but does it really factor?
No.
No. There's no factors of 4 that make 6, so I can just stop. That's f prime. So if I want to know the slope of this function at 3, what would I do right now?
Plug in a 3.
Plug in a freaking 3. So it doesn't matter what rule or whatever, f prime always means the same thing. It means the slope of that function at whatever point. Doesn't matter how we got there. The minute I got f prime, that's the slope at any point. Can we stop for a moment?
It might be an ugly line, huh?
Sure. Poor little dude. Yes.
Why can't you cancel out the 2x plus 3?
Say again?
Why can't you cancel out the 2x plus 3?
Because this is also divided by 2x plus 3 squared. So you could break these up into 2 parts, but that seems kind of silly because normally you want to combine them, so might as well keep them together. So, alright, if I have xy divided by x, can I kill the x's? Of course I can, because division cancels multiplication. If I have x plus y divided by x, can I kill the x's? No, because division does not cancel addition. If I broke them up, then I could cancel them. But why break this up? I'd rather have it together as one fraction anyway. Yeah. Does that make sense? So you could, but we normally don't want to. Yeah.
Can you do the math again for the first row? 'Cause I'm not. I mean, the top of the.
Here?
Yeah.
Oh, I'm sorry. I should have just done it. 4x squared minus 2x squared
Okay.
is 2x squared.
Oh, so you're multiplying the 2 into the.
Yeah. 2x times 3 is 6x minus negative 2 is plus 2. Okay. And again, you guys, I'm just trying to, for the sake of time, you guys could all do that. Okay, so last new idea. Then we'll get into a review. Trig. So I've got, there's one little thing I want to talk about that we need to make this for sine make sense. And that is this thing. Let me write it like this. Let me see. Limit as x goes to 0 of sine x divided by x. This is something that I come back to when I teach Calc 2, Calc 3. I come back to this moment. Because you learn some more shit, you can come back and look at this in a different way. But for right now, we only have one way to analyze this thing. What's the one way I have to analyze this thing? I'm not taking a derivative, am I?
Oh no.
I want the limit of this.
Plugging in 0.
That's not asking for a slope, it's not asking for any of that. Yeah, what happens when I plug a 0 in? What do I get? It's 0 over 0, yeah? Okay. Sine is 0 is 0, is that cool? Okay. So then the answer could be almost anything. It's indeterminate right now. But there's no algebraic thing I can do here. You guys agree? I can't like rewrite sine, I can't break it, I can't factor it, I can't do any of that stuff. So what's the only thing I have to analyze this?
Derivative rules.
That's right, a table. So if I,
Oh.
sorry. What do I want to put into this table? So this is the first problem with the quiz, and a lot of people got the same thing for me. Get close to blank. What do I want to get close to? 0. So am I going to put 4 in here? No. So I'm going to put like 0.5, 0.1, 0.01. Is that cool?
Yeah.
I can go from the other side too. Negative 0.99, negative 0.9. Okay, that should be plenty. So if you do this, just to remind you guys, if I put the function I'm working with in here, make sure we're in radians. Jeff, if you put it in there the right way, things will be great. Make sure we're in radians. Mode, radians, yes? Okay. Go to my table, delete this shit, because I don't want it. I want this first one. There we go. Is everybody with me so far? Put the function I'm curious about. Go to my table. Does your table look like this? If you're playing along? Ready? Go to table set at the top. Above window it says table set. Go down and make this say ask. Auto is going to fill it in itself. Ask is going to wait for you to tell it. Make the first dude independent, make it ask. Yeah. Make the first dude ask. So now it's going to wait for me to tell it. It's asking me, what do you want? I want 0.5, I want 0.1, 1.01, negative 0.99. That doesn't make any sense, John. Yes, no it doesn't. Where am I going to? 0. So this doesn't make sense, John. You're almost there, buddy. Negative 0.01, negative 0.1, that's better. So negative 0.01, I don't know why I was going to negative 1. Oh, here's a cool thing. Okay, I just made a mistake. Syntax error. If it ever says go to, yeah. Do you see I have 2 decimals? Good job, Jeff. All right, so now you can pretty much see where this thing is headed, yes? Where's it going? 1. I love it. So this is 1. That's neat. What this really says is when the angle for sine gets small, it's the same as the angle itself. So let me check that real quick. Everybody do this with me. What's the sine of 0.007? Make sure you're in radians, right?
0.007.
699. So if you round, don't you get 0.007? So when the angle input is very small, almost 0, the output is basically the same thing. That's what this means. If the limit of this is 1, that means that when x gets small, sine x equals x. That would make this ratio 1. Are you guys with me? When you get really close to 0, if you multiply x up, you get sine x equals x. So when x is really, really small, sine of an angle equals the angle, or really close. Okay. So looking at this, if I had written this down, much better than I could write by hand. Just very quickly. If you want to know the derivative of sine, you got the limit definition. Do you guys remember this identity? What's the sine of a plus b?
2.
No. Sine of a plus b. Sine a cosine b. Sine's the nice guy. Takes turns. Hey, cosine, come here. Sine a cosine b. Plus, because there's a plus sign, leaves it alone. Sine b cosine a.
Oh, I was thinking
You guys remember that?
double.
Cosine of a plus b, he's an asshole. Cosine of a plus b is b first. Cosine a, cosine b. You got a plus, make it a minus. Now you do shit sign, right? So cosine's an asshole. So if you took me for trig or pre-calc, I explained to you why cosine's an asshole. Okay. We're going to learn more reasons this semester why cosine's an asshole. It keeps going. So all I did here was sine x cosine h plus sine h cosine x. I just used that rule, yeah? Okay. Then I can break this up. This over h. I kind of brought the limit in for some reason. So I get, as h goes to 0, what's the cosine of 0? 1. So that's where the sine x comes from. Don't I have another sine x over there? So this just goes away, yeah? So then it all boils down to this piece. And we just figured out what this is. 1. So that becomes cosine. So what's the derivative of sine?
Cosine.
Cosine. Now what's really interesting, so if I have f of x equals sine, f prime of x equals cosine. So what would be your guess if I have cosine? What's the derivative of cosine?
Negative sine x.
That's probably not your guess. You already knew that, but yes, it is negative sine. And very quickly, doesn't cosine look like this? You guys should know that cosine starts maximum, right? If isn't the slope 0 here? Yes? Isn't the slope negative here? And then isn't the slope 0 here? Doesn't that look like negative sine? Doesn't it look like sine's been flipped? That's exactly what this is saying. The derivative of cosine, if you actually draw it, becomes negative sine. I could do something very similar to this derivation here to show that. So now we know 2 trig rule derivatives. Derivative of sine is cosine. Derivative of cosine is negative sine. There's why cosine's an asshole. Its derivative is negative, damn it. So I can finally give you a problem like this. I want to know the derivative of this. Go for it.
Can I turn this dude on?
Yes. What rule do you have to use? Product rule. And of course the trig, yeah. So h prime. So take the derivative of the first guy, leave the second guy alone, plus leave the first guy alone, derivative of the second guy. The more complicated our functions become, the more I highly recommend not doing derivatives first. Just apply the rule. Because then you're getting practice with the rule, and then you can focus on, then the whole problem becomes that. And like I just heard somebody say, that's easy as shit. What's the derivative of x squared? That's your whole problem right now. A lot of other shit, but I don't care about it. That's all I worry about right now is that. That's 2x. And what's the derivative of cosine? This cosine's an asshole. Good. So then I get 2x cosine x minus x squared sine x. Shlabam. So if I have this function, and I wanted the slope of that function, I could use this function to determine the slope, right? So I can ask you the same kind of question. Find the equation of the tangent line to this function at some point, and then this will be the first thing you do. You guys all with me? That you're going to see that same problem over and over again. You're just going to have different functions thrown at you. So let me ask you this. How would I figure out the derivative of tangent? Beautiful. I know sine and cosine derivative. I also know quotient rule. Tangent is sine over cosine. All right, I'll wait. You guys figure that out. What's the derivative? Sine x over cosine x. Oops, sorry. So if you write the rule out, it's the derivative of the top times the bottom minus top times the derivative of the bottom. So each piece gets its own term divided by what? T-gas. Derivative of sine is cosine. So I get cosine squared x. Is that cool? Cosine times cosine. And then what's the derivative of cosine? Negative sine. So then negative sine times sine is negative sine squared. So that becomes plus sine squared. Is that cool? That's negative sine. Negative times negative is plus. Sine times sine is sine squared. So everybody with me on that? Yes. So again, the derivative of cosine is negative sine, yes? Negative times negative is positive. Sine times sine is sine squared. Yes?
What about the cosine in the denominator?
I just haven't written it yet. Huh?
No, the cosine of, but cosine squared x. Where'd you get that in the first step? Oh, in the
That's the rule. Quotient rule is f prime g minus g f prime, I'm sorry, f g prime over g squared.
Oh, okay.
Square of the bottom, yeah. What's cosine squared plus sine squared? 1. What is 1 over cosine? Secant.
Yeah.
So what's the derivative of tangent?
Secant squared.
Secant squared. You wouldn't have come in knowing that. But now we know that. Now we know that's what it is. So you can memorize that. In fact, not you can, you must. Alright, so last little piece, and then I'll kind of show you what the rest of them are. What about secant? How can I figure out that derivative? How can I rewrite secant in terms of something we already know?
1 over cosine.
1 over cosines. Isn't that quotient rule now? It's a very weird quotient rule because the top is constant, but all right. We just did quotient, so you guys help me out. What do I take the derivative of first? The top minus the top times the derivative of the bottom, all over bottom squared. That's the quotient rule. So what's the derivative of 1?
0.
This is what trips me up. People will do this and somehow this is alive. 0 times cosine is 0. He's dead. So I get -1. What's the derivative of cosine?
Negative
So I get sine x over cosine squared x. Yes? That sucks. Let's make this better. I get sine x over cosine x times 1 over cosine x. What is everybody agreeing with me that's cool? Is that cool? And you're like, yeah, you can do that if you want to, Jeff. What's sine x divided by cosine x? Tangent. And what's 1 over cosine? Secant. So here's a very trippy derivative. If I have secant, its derivative is secant tangent. Yes?
So if you were to test this, that's what you're looking for. If we get down to tangent x times secant x, you want us to write it in this one.
So for now on, you never have to do this. You now know this fact. You now know the derivative of secant x is secant tangent. Secant tangent, I don't know why I said that. So here's the first level thing, just to truncate this a little bit. I can do the whole damn thing we just did with cosecant, correct? Here's the beautiful thing about the cos stuff. The derivative of cosecant is related to this. Secant is secant tangent. What's your gut tell you cosecant's going to be? And that's almost right. It's just got a negative in front. So all the cos stuff, what did I just do? Okay. All the cos stuff is negative as a result. What's the derivative of cosine? What's the derivative of cosine? Negative sine. What's the derivative of cosecant? Negative stuff, right? What was the derivative of tangent?
Secant squared x.
Secant squared. So what do you think the derivative of cotangent is? Negative?
Secant squared x.
Cosecant squared x. That kicks so much ass. Thank the gods. There's really nice symmetry there, so it makes it easier to memorize, correct? Alright, now the lights are doing it. One little things. There we go. Okay, I like it. Do we do all of them? What about cotangent? Yeah, we just did it.
We just did that.
All right, we did all of them. Good. Yes. Yes, I can. I can totally do that. So just to show you in the book, page 150, I'm sorry, 194, they've got all the derivatives up here. Okay, so does everybody have a, oh shit, where have I put mine? I had some practice tests up here somewhere, but. They're gone. Oh, here they are. Does anyone else need a practice test?
I get an extra.
Anybody need a practice test? All right, guys. Has anyone looked at the practice test yet? It's okay if you haven't, because you got enough homework to worry about.
I looked at it.
You looked at it? Okay. I made it as far as. Is there something on here I need? No. let's see. 13, yes, 13. So let me do this. Very first thing we need to do is talk about what can be thrown alpha here, because now we're not going to make it through 3-4. Homework that's due Thursday is through 3-3. We didn't make it to 3-4. 3-4 is chain rule, which is one of my favorite things. So the stuff you cannot do, for example, is 13G. You can't do 13G. You can't do 13D.
You said C up when we were.
Yeah, C you can't do because of this piece. We haven't gotten there yet.
The 3 is the X.
God dang it, you can't do this one.
That's what I didn't want to do.
Yeah, okay, you can do everything else. You can't do C, D, E, and G. Yes. We're gonna get there. I just want to make sure I got all those. By the way, we will be getting these problems on the next test. Okay. Can't do 14. Now, I want to tell you this. I am going to give you a problem like 14, but I have to put something here we can do. The reason we can't do this, I want to make sure you understand. Chain rule is all about when the inside is more than just x. That's what chain rule is. I know what the sign of x derivative is. You do not at the moment know how to do the sign of 3x squared minus 7x inside. You don't know how to do that. That's what chain rule does. It says, holy shit, what if your inside has got a lot of stuff going on? The derivative gets a little bit freakier, just a little tiny bit. Is everybody with me so far?
Yes.
I think
Problem like that.
everything's fine. So if I gave you a problem that, you know I'm going to ask you to find the tangent line. You know I am. But I'm going to give you a function we actually do. Yes?
Well, that's what I was saying. You give like an example one.
Yeah, so I would say like x to the 4th minus 7x cubed plus 3. Right, for example?
Yeah, cool.
And you can find it where that would be horizontal. I'm not saying that's going to work nice. I'm just saying it's the kind of problem I would give you. Did I say that was a square? I don't know what I said. Okay. I think, yeah, everything else is fine. Everything else is fine.
That's squared, right?
It's cute.
Was it cubed?
Yeah, you said cute.
I can't remember what I said.
Oh, it's cubed.
Come to find out, yes. So for example, number 14, if I use this equation, what would I have to do to figure out where it's horizontal, where the tangent line would be horizontal? What do I have to do first?
Find the derivative.
Find the derivative, because horizontal tangent line is all about the slope. So I need the function that describes my slope so it can answer a question about the slope. Yeah?
Can you work number 6?
In a minute. I want to do these first because I didn't do any of these. So what is the derivative of f?
4x cubed
4x cubed?
minus 14x squared.
Well, that's a 3, I'm sorry. That's a cube.
Oh, 20
Minus 21.
1x squared.
X squared? Good. And then I want that to be equal to what?
0.
0, because I want it to be horizontal, so I want it to be flat, so I want the slope to be 0. Hey, guys. See you. Okay. Some old students, I'm sorry. Guys, we saw a problem like this earlier. Horizontal, 0 slope. Oh, so I need the function that describes slope, so I can actually make that match up. How do I solve this equation? Row.
Take out a.
Take out, good, factor the damn thing. So take out, how many x's? 2. Good. I don't know if your brain is not liking the fact that it's going to have a fractional answer eventually, but we're in calculus. We're going to get fractions, okay? So what's one answer? 0. What's the other answer?
7.
No. If that was a 3, it would be 7.
Oh.
Add 21 divided by 4? Yeah.
Oh.
I'm with you. That was an optimistic part of your brain.
Yeah.
Okay. That's number 14, by the way. It just kind of like bled over into number 15.
Then you gotta find the equations for both of them.
Number 14 says find where the tangent line would be horizontal.
Oh,
Number 15 says find the equation of the line that is tangent. Right? So number 15, how do I do that? Find the equation of the line that is tangent to this curve at 2.
You do y minus, you get to find
So then you're gonna,
y.
So what 2 things do I need for the equation of any line?
you need
A point
and a point.
and a slope. So do I have a point yet? No.
We don't have y.
Plug it in.
Yeah, good. So I want to plug in. So let's get a point first. I need a point and the slope, yes?
Yeah.
Anytime you see a question that says find the equation of the line that does stuff, I need a point and the slope. That's it. So what's the point?
2 something.
Good. 2 negative 10, I think, right? Just plug a 2 in. So if I want to know where the function is, I got to use the function. If I want to know what the slope is, which is what we're going to do next, I have to use the derivative. What's the derivative?
3x squared minus 9.
Now, where do I want the slope at? X equal
2.
2.
So plug in.
So we've done several of these problems, and this problem is going to show up every time we learn new derivatives of new functions. This problem is going to come up again. Yeah.
Just semantics. You call when you have x squared equals 0 from solution a root of second multiplicity, right?
Sure. Multiplicity 2, root of multiplicity 2, yeah. Multiplicities will come in handy later when we start using calculus to help us graph stuff. So if you remember your pre-calc and you had a graph based on how many turning points and what the behavior was at each root, does it go through, does it turn? I don't know if you guys remember that this late, not yet. So what is my slope then? So I just plug a 2 in?
Oh.
So what slope do I get? Yeah, 3 times 4, 12 minus 9 is 3. So the slope is 3, and the point is 2 negative 10. You can make an equation of a line, yeah? You want to see it here. Here's the way I do this. You ready? The way I do problems, I do very little work. So I know the slope is 3, yeah? Yes?
Yes.
So I know the answer is going to look like this, and it's going to have some extra shit here, yeah? So I know at 2, I'm supposed to get a negative 10. Well, at 2, what do I get so far? 6. So I better subtract some stuff to make it negative 10. I'm going to subtract 16. I'm freaking done. That's what I do. So I know that's going to be part of the answer, correct? Because the slope is 3, yes? At 2, the output's supposed to be negative 10. Right now, I get 6. Well, if I subtract 16, I get negative 10. I'm done. Do you have to do it that way? Of course not. Holy shit. You could do the solve for b, you could do the y minus y1. Okay, I like it. This one, on the actual test, I'm going to give you a graph, and I'm going to make you graph f prime. We did some problems like that. It's like from section 2.8, if I remember correctly. They give you a graph, and you have to graph f prime.
Yeah.
Okay. This one I did this, I made you do it on the graphing calculator. So for example, if you do this, x cubed minus, where'd it go? 3x squared. Oh, my, go to zoom 6 right. So it looks sort of like what we'd expect for a cubic, right?
Yeah.
What are the most important points that I see on this graph?
The min max.
Where the slope is 0.
Where the slope is 0. So the min max where the slope is 0, because then I can immediately plot. So if I do it right on top of this guy, it looking so weird by the way. Poor little dude. I don't know. Okay, too bad. So on the test, I'll give you this graph so then you can just you just plot over it. So what are the first points I'm going to plot for my prime?
0.
Yeah, so the slope here is 0, and the slope here is 0.
Yeah.
That's a coincidence that the value and the slope are the same. Because if I could just lift this thing up, it would, you know. What's true about the slope here?
It's increasing.
The
What's
slope
It's positive.
is actually decreasing. But the slope is positive or negative?
Positive.
Do you agree with me that it's decreasing?
Yes.
Because here it goes to
Negative.
0. So the slope here is positive and it's decreasing to 0. Do you see that? And that again, this is the part where your brain tries to take over and you're like, no brain. You gotta really, really focus, right? You got to really be aware of what's going on. I am plotting the values of the slope, and the slope is big positive, and then it gets smaller positive to 0. What's true about the slope now?
It's still going
Well,
down.
not still anything. It now is negative slope. And then somewhere in here, it's the most negative slope because then it starts to go to 0. Do you guys see that? Anybody know what the name of that point is I keep talking about? Inflection point. Do you have to know that yet? No. Poor little dude. Okay. Oh, Scheisse. This is the dangers of doing this. That didn't take much, did it? Okay. There we go, sort of. Okay. So now it's negative. Somewhere in here it gets the most negative, and then it turns to go through that. So it's negative, and then it's less and less negative until it's 0 again. Is that cool? And then what happens after that? It becomes positive, and it's growing. It's more and more positive. Now, what matches with the rule we know? This looks like x cubed, and of course we know it was. In fact, what am I doing? What was the function?
X cubed minus 3x squared.
What's the derivative of that?
3x squared minus 3x.
6x. Yeah.
Yeah, 6x.
Yeah. So, let me see if I can do this without moving it. If I put in here 3x squared minus 6x, let's see how good my... Hey, look at that, it's not bad.
Can you just, so, you're gonna.
That is exactly, now real quick, I'm sorry, Brandon, real quick. By hand, before we learn what derivative was, before we really learn how to get it, you could trace it out. Now that you know how to frickin' do it, you could trace it out and then check yourself. So look, was I perfect?
No.
Hell no, I'm doing it by frickin' hand. Did I get really close? I got pretty close. This was a little bad, but oh well, I'm okay with that. So you don't have to be perfect, obviously. We're doing this by hand. We're freaking humans. Holy shit. But you can kind of check yourself. Now, if it's too perfect, kind of like you just copied from the calculator, holy shit, don't do that. You with me? Okay. Yeah.
Sure, how, does it matter how far down here for the points, like for the?
Not for just what we're doing.
No?
No, that's way too far beyond what we're able to do just by hand and observation.
Okay, so just bring it.
Just kind of wing it by hand, right? It definitely doesn't go too far down, because then you gotta like, whoa, right? Yes.
So when you give us a problem like that and we don't have to use a specific rule, can we just take the derivative and then graph it like that, basically?
What I just did? Yeah.
Yeah.
Just to check your work, yeah. But don't let that be your work. That's my point. Yeah. Yeah.
Are you ready to move to problem 6?
Yeah. Sorry, I just wanted to finish all these because I didn't put them on the answer key. So let's look at problem 6. Yeah. This guy?
And 5 too.
5 as well, okay. Oh yeah, I have, okay. I have not talked about squeeze theorem yet, which is driving me crazy, but if you're gonna leave, make sure you get the answer key. Oh yeah, sorry. Always forget to do that. Don't apologize. Just say, hey man, you forgot to raise. It's a multimedia thing going on. Let's do 6 first, because number 5 is going to take a little bit of explanation. Can anyone tell me, where are the places this could be discontinuous? Where's the most obvious place this could be discontinuous? Pi over 3, because they could not match up. Maybe somebody defined it so it didn't match up. Now, where else beyond that could it be discontinuous? If one of these functions has an issue somewhere. Like if this was 1 over x, would it have a discontinuity where it's defined? Yeah, because 0 is less than pi over 3, it would have a discontinuity of 0. So 2 levels. Do the functions have issues? And then you always have to check, is there an issue with the handoff? Do they not, like I think about a relay race, if somebody's holding the baton out and the person's way over there, it ain't gonna work, yes? They gotta match up. Okay.
Do either one of these have an issue anywhere? We know from that theorem, from the continuity section, all trig functions are continuous on the domain. And what kind of function is this? This looks horrible, but do you see how it's not?
Yeah.
What kind of function is this?
It's a squeezing of the 6.
No. It's a line. What's the slope of the line? Negative 6 over pi. Now the slope is gross, but it's just a stupid, it's just a line. Yeah? Okay, so does a line have an issue anywhere? No, it's defined everywhere. Trig function, defined everywhere in its domain. It's good. Its cosine's domain is? Domain is? All real numbers. So neither one of these have an issue. So the only place this could have an issue is pi over 3. So how do you check if that's an issue? Plug it in. Where is the person with the baton and where is the person's hand reaching back for it? Yeah, do they match up? If they don't match up, that race is not going well. Yes?
Okay, kind of going based off of what you said before, let's say we just did cosine of pi over 3, right?
Well, it's
Right, but like assuming that that's just like, cause I'm relating it to whenever you said cosine is 1. And if we put the number in front of x, then it was just.
oh,
Like the-
are you overanalyzing what this would do to the graph?
Probably, but let's just say that at pi over 3, if we just looked at it like cosine of pi over 3, aside from that, like that's just gonna make it larger in,
This would squeeze it.
yeah.
Now, do I have to think about this problem like that? No. If I plug a pi over 3 in, what's the first thing that happens? When I plug a pi over 3 in, what happens? The 3's cancel.
Yeah.
What's the cosine of pi? Negative 1 times 2. Negative 2. So at pi over 3, this would be at negative 2. Now, can it exist at pi over 3? No, but we're looking at the limit. So the limit as x goes to pi over 3 is negative 2. What about here? If you plug a pi over 3 in, pi over 3 times 6 is 2 pi. Over pi is 2, and there's a negative. So they're both negative 2. So that one's fine. You guys see that? So the specifics about this problem don't mean shit. If I give you a piecewise function and say, show me it's continuous, or find where it's discontinuous, look at the functions. Do they have any problems? And then check them both. Do they agree at the handoff place? Okay. So if nobody's asking questions, it's wide open. You can ask any question you want to, hopefully related to calculus. Yes?
Okay, so then when you do 6 times pi over 3?
Yes. So 6 divided by 3 is 2. Right? Okay, so 6 times pi over 3 negative over pi, right? 6 and 3 reduced to 2. Pi's cancel, you get negative 2. Yeah. Yeah, you just gotta write it out for yourself. So let's talk about squeeze theorem. Finally. It's one of my favorite things. Okay. I think I gave like 2 problems about squeeze theorem. So imagine there's a situation where there's a function that exists between 2 other functions always. Whatever these functions are, f is always between these 2 other functions. So for example, if I draw, and let's say that the limit as x goes to a of g of x equals the limit as x goes to a of h of x, and that equals L. So the limits of the 2 at the ends are the same at a. So what does that mean concretely? That means that what's the biggest function up here always? What's always the biggest? H. It's bigger than both, yeah? So here comes H, and at A it's got to be approaching L. Right? So at A it's approaching L. G of x is the smallest dude, yes? So he's going to come along. He's always got to be below H. Except right at A, bam, they have to both meet, yes?
Where's f of x? Always gotta be between these two. So what do you think the conclusion is? If f of x is always between these two, what's the limit as x goes to a of f of x? Say again? It's gotta be L. I can't escape. It's like it's gotta exist between. So it's trying, and then this is why we call it the frickin' squeeze theorem. If I always gotta exist between these two walls, and the two walls close, I'm gonna agree with where those walls are. I don't have any other option. They've squeezed me down to one option. And then after that, I can go crazy between these two, or I can go straight, or I can do whatever the hell. As long as I exist between those two, I'm good, yes? Mm-hmm. This is why we call it the squeeze theorem. Now, on the surface of it, it might sound like, great, okay, when does that happen? Well, it happens more often than you think, but not that often, to be honest. So what kind of question would you get? Okay, here's an example question. I want to know what's the limit as x goes to, it doesn't matter, 0 of x squared times sine of 3 minus pi over x. Do you feel like trying to figure out that limit?
No.
Do you see how that would be possibly disgusting?
Yeah.
So, watch what I can do. Watch what I can do. What piece of this is bounded? I don't know if I've said that word yet. Sine is bounded. Now look, the inside of sine is disgusting, yes? Does that matter? The outputs, I don't care what the inputs look, what do the outputs have to do? Live between -1 and 1. So if I take this piece, I'm going to write exactly what you just told me. This lives between -1 and 1, yes? Now is that the function I'm curious about? Not quite. What am I missing?
X squared.
So now I'm going to multiply everything by x squared.
Why is it -1 and 1?
Sine and cosine. What do they live between?
Oh, yeah.
So I don't care what the function on the inside looks like. The outputs must go from -1 to 1 for just sine. Yes. If I multiply everything by x squared, I'll get -x squared less than or equal to x squared sine less than or equal to x squared. Okay, so they're all like, good, way to go, buddy. But now if I take the limit as x goes to 0 of all of these things, what's the limit as x goes to 0 of -x squared? 0. Limit as x goes to 0 of this, I don't know yet. We're just taking the limit as x goes to 0 of each piece. What's the limit as x goes to 0 of x squared? 0. If 0 is less than or equal to this is less than or equal to that, what must this limit be? 0. Squeeze. It can only be 0. It's got to be greater than 0 and less than 0 or equal to. So it's got to be 0. That's the only thing that could do that. So therefore this limit equals 0. Kabam. That's squeeze theorem. You identify the part that is bounded, and then you build onto it what you need. Yes?
Would you mind giving an example of y bound between e to the x and -e to the -x?
Is that from a homework problem or something?
I just made it up.
So tell me again.
Y equaling mx being bound between e to x and -e to -x.
Okay.
Does that even work?
I think I know what you're trying to get at. There's a really cool idea if you do this kind of thing. If you do this kind of thing, this would be what's called a dampened oscillator. I'm sorry, if I do this, there we go. The number that's in front of sine is the amplitude, remember that?
Mm-hmm.
So it was a 3 in front, it would go up to 3 down to -3, you with me? Yeah. So what's the number in front of sine? Is it a number?
No.
Oh, it's a function. As x gets big, doesn't this go to 0? You guys see that?
Yeah.
Because it's 1 over e to the big squared. So that would be these, and then sine just kind of lives between them. That would be what's called a dampened oscillator. When I pluck a guitar string, thank the gods that the sound waves get smaller over time so that not every guitar is still going. They eventually die out.
That would suck.
That would suck so bad. I don't know if that's what you're talking about.
I was thinking if you got e to the x, negative e to the negative x, and y coming through the origin, that would be bound by the two exponential.
But the whole point of squeeze theorem is the limits have to agree at a point.
Right.
That's the squeeze.
Yeah.
So you could modify that
They
maybe
can modify it.
to make it, yeah. So anything would work for squeeze theorem as long as a function is always between these two and as long as at some point these two have the same limit. That's the squeeze part. But it must always exist between these two functions, and at some point those two functions touch, I've got no option except to agree with them there. That's the whole point of squeeze theorem. Is it a major thing? No. So am I going to talk about it any more than this? No, that's it. So there's one problem, I think, yeah, number 5.
Yeah.
Which part of this is awesome? Oh, I almost made exactly the same problem. Way to go, Jeff.
I thought that's what you did.
I didn't mean to. I wasn't even remembering what this was. This is just a classic.
Yeah.
What part of this is oscillating?
Sine.
Yeah, that part. So if you make that go from -1 to 1, and then you multiply everything by this,
Yeah, okay.
that'll show up in the middle. Then when you do the limits of the outsides, they go to 0, so therefore the limit of the inside must go to 0. Maybe. Yes?
So basically, the whole time squeeze theorem is equal to 0, it's just you're showing the complex work of whatever's on the outside of the sine.
Yeah, it's when this
You just wanna see
function,
the work.
when I don't really have any good limits. Can I do anything algebraic to this? Can I cancel anything? No. So the squeeze theorem comes along and says, I might be able to help you out.
Okay.
Is it useful a lot? No. Is it useful? Yeah.
Are we gonna have to factor the squeeze theorem? Use that?
You have to use the squeeze theorem?
Or we're gonna have to factor?
I don't know what factor means. We don't
Like
factor. Yeah.
Well, we use it on the test.
Yes. That question I can answer. Factoring squeeze theorem doesn't really make sense.
No, I'm saying like when we're doing squeeze theorem, are we gonna ever have to factor anything inside?
No, sorry. These are one thing, sorry.
Oh,
Yeah.
I'm gonna give everybody 2 sheets, and that makes up the key. Don't give your sheets away. Yeah. It goes up.
How you feel?
So
Brandon?
Yeah, probably did the other one.
How do you feel?
I'll be alive. I'll be alive. I'll be breathing. Sound
I don't know if the questions are getting worse or if I'm losing motivation.
Yeah.
Let's go.
Yeah.
You never put it, you don't know what it's equal, right?
Oh.
You never put it in.
You didn't finish the problems.
Yeah. Yeah. On the last one, is that the answer?
That might,
13I doesn't have an
that might just be the answer.
and you just put an equal sign back.
No, 3.
Oh, wait. That might just be the answer. Let me go.
Can you believe it? I went back to the bookstore, right? How much of a charge? Because my phone was at like 6%. Right? So I'm sharing my phone, right? But I'm gonna set that charger. So, yeah. So much aside. So, you know what I'm gonna do? What I'm gonna do
Alright
is
guys,
different.
anything else you would like to discuss? Yes.
On the very last one, is that the answer?
I don't know. Did I make it all the
You
way?
just wrote equals.
You just wrote English.
I was wondering.
Yeah, I was helping people in my office. Oh yeah.
Yeah, that's just the
I
answer.
just have to foil out for that one. Yeah. Yeah. Just simplify it.
Offer it not to work.
Alright.
So I was like,
Just to kind of let you guys know,
I felt very disconnected today because I have like a backlog of answers. I could not find this one to save my life. So this morning I finished grading the quizzes, I graded most of the homework, and I made this answer key. So those of you that came to my office, you saw me answering your question and then turning back and trying to do as much as I could. So that was what made me a little less together today. But I wanted to give you at least most of the questions answered so you can kind of use that, but the rest of them will be up on that video. Anything else from the practice test or homework you guys want to talk about? Yeah, the quiz. Let's see. What did that one? Let's see. That was yours the cubic or no? There was. Yeah. Okay. So guys, let me warn you about this. So on the quiz, remember there's a cubic. There was a cube that you had to factor. I could put that on the test, or I could put any other factoring thing I want to on the test. So you got to remember your grouping. You got to remember your. The one that people normally forget is a problem like this. If you want to head out, you can. It's fine. I won't take it personally. If you have a problem like this, how do you factor this? You can guess and check till you go crazy. So let me do the first step. Does anybody remember this? This is where you make the little X, and that's magic. It's the same shit I'm about to do. What multiplies to be negative 24 and adds to be negative 5?
6. I mean negative 6.
8 and 3 if the 8 was negative. Yes? So instead of saying, if that wasn't there, I would say what multiplies to negative 6 and adds to be 5, yeah? Negative 5. That's there. It's gonna mess shit up. So what's my next step? Would be rewrite the middle term using the numbers I just got, and then I've got grouping, which is relatively easy, yes? Okay. So for example, real quick, if I had 2x plus 7 times 3x minus 4, okay, just go with me for a second. Don't I get 6x squared? Mm-hmm. And then I get minus 8x plus 21x minus 28, is that cool?
Yeah.
Can somebody, and then I can combine the middle terms, yes? Mm-hmm. So obviously, one thing I want to point out, obviously, when I go to factor this, I can't find factors of this to add to be this, because that's not what made 13. There are no factors of 28 that add to be 13. And there's not supposed to be, because that's not what I have here. What is 6 times 28? Help me out. I can do it in my head, but I wanted to see what you guys do. 6 times 28. 168. What is 8 times 21?
168.
100 frickin' 68. So, what does that have to do with anything, Jeff? If I do 6 times 28, I figure out the number that these two would multiply to be, because that's always how this works. The parts of this stupid thing, 2 and 3, they screw my middle term over. Yes? Mm-hmm. Do you guys see that? So that's why the method to factor, I have to take that stupid thing into account. I got to multiply it by this because that's actually, it got multiplied into the whole mix. That number is what I want to find factors of that add to be the middle term. Is that okay?
And that's the
Can you show them the top where you did the little branch?
So if the problem would have been this, it would have been much easier, yes?
Yeah.
What multiplied negative 6 add to be negative 5? Be careful.
1 and 5, but it's negative 5.
Negative 6.
Negative 6 and 1, not 2 and 3, right? 2 and 3 make 5, but they both have to be the same sign. So that's very evil. And then I'm done. I don't have to do any extra shit because it's just a 1 out front. By the way, didn't I do 1 times negative 6?
Yes.
We just didn't realize that's what we did because it doesn't matter. 1 doesn't change anything. When the first number's not a 1, oh shit, it changes stuff. Yes?
This is not the same problem.
Sure.
How did you, the way you solved number 7 was confusing a little bit.
Let's see what past Jeff did. Oh, this is the epsilon delta thing, right?
Yeah.
So I did my side work, yeah? I started with the result, and then I kind of simplified that. Then I got what my delta had to be, yeah? Then the great thing about this step here, people always get confused about this. There's no guessing, there's no work. I just copy this backwards. So if I let delta equal that, that makes this true. That's the proof. This is a baby proof. And what's funny is the minute it makes sense, that's the minute you're like, well, this is kind of silly because I already did all over here. But that's the construction of the proof. Yeah?
When we had the branch,
Sure?
there was 3 roots. I counted 3 roots, but it's a quadratic, so you only have 2 roots, right?
3 groups, what?
3 roots.
I'm not done factoring here, right?
You would have 3x minus 6, 1 factor, and x.
No, stop. What comes out of here?
X.
X squared. What else? I'm not X squared.
X.
Let me rewrite this over here so I'm looking at it better. Yeah, 4x, yeah. Do I have paper? Yes. All right. Yeah. All right. How do I factor this? You can't go against the fundamental theorem of algebra, which says this is going to have 2 answers.
Yeah.
So what comes out of these two? 4x. What's left?
X minus 1 minus.
What comes out of these two?
3.
What's left?
X minus 2.
What tells me I'm on the right track? These are the same, so they can come out, and I'm left with this guy. Right? So then I get 2 answers if I set it equal to 0. Now what I love is students make everything equal to 0, which is a very nihilistic approach to the universe. If this problem just said factor it, don't set it equal to 0. I don't know what the shit this equals. So don't force it to be 0. Yeah. So if I just say factor this, don't set it equal to 0, I have no idea what this equals. Depends on what x is, I don't know. Yeah.
There is the one with the X, right?
And those of you who do this, and then you put this here, is that true? Anybody do this to factor? And then you put the numbers here that multiply to be this and add to be this. Same work, just organized differently, and somehow that makes it make sense. I don't care. If that somehow does magic and it makes sense, use it. As a teacher, as me, I don't understand what that does. But something that does something mentally for people, which is fantastic. If that makes it make sense, do that. I don't care. Yeah.
Can you go over a problem somewhere?
Does that answer, I'm sorry, did that answer the question?
Yes, yeah, that
Okay.
I didn't remember how it's working.
Yeah.
2, the one where it's like 3 square root of 4 like 16.
Oh, this guy?
Yeah.
Yeah. Okay. Somebody else was asking me about this in office hours. What part of this talks about the domain? What would it influence the domain?
The inside?
The inside, good. And it's inside of a 4th root, correct? So what cannot be true, or what must be true about this thing on the inside? Positive or?
Negative.
It can't be negative, right? I want to stay real, correct? Unless the problem says we're using complex numbers, I need to stay real. This will become complex if the inside is negative. So the inside's got to be at least 0. Does that make sense? So, instead of doing algebra, I could just reason this out. I used to drive my physics teacher crazy. Once physics teacher said, "Do you know math?" And I said, "Yeah," because I was answering questions conceptually instead of mathematically. And I'm like, so what you can do here is, when will this become negative? If I do 16 minus a number bigger than 16, correct?
Yeah.
So when is x squared equal to 16?
8.
squared?
Four.
4. So if I put a 5 in, does this thing freak out?
Yes.
So the highest I can go is 4, yes? What else squared is 16? 4? Negative 4. If I go down in negative 4, I'm okay. If I go beyond negative 4, if I plug a negative 5 in, don't I get 16 minus 25 in? Isn't it negative again?
Yeah.
So do you see, it might sound weird coming from a math teacher, but a lot of these problems you don't have to use much math on. You can reason this out. The domain of this guy has to go down to negative 4, up to 4. That's as far as I can get away, because if I go any further, I'm subtracting something bigger than 16 from 16, that's negative. Now, how do you do this algebraically, right? 16 minus x squared has to be at least 0. Yes? So then 4 minus x times 4 plus x become a plus, has to be at least 0, yes? So then you got to do this kind of stuff. When is it equal to 0? Negative 4 and 4, yes? I don't know if you guys have ever done this. In between these two, if I put a 0 in, what kind of number do I get? I get a positive number, yes? You guys see that? If I put a 0 in, I get 4 times 4. If I put a 5 in, what kind of number do we get? 4 minus 5 times 4 plus 5. I don't care what the number is. What kind of number is it? Negative. If I put a negative 5 in, I get 4 plus 5 times 4 minus 5. What kind of number is that? Negative. Do you see how I need things to be at least 0? So then what works? Negative 4 to 4. That is the algebraic way to do this problem. That is more work than you need to do. Yes?
Okay.
I think I did, I can't remember what I did in the community, to be honest.
Yeah,
This morning was a blur.
You just put negative 4 to 4.
Oh, okay. I'm so explanatory.
But no, for real though, like, you always say to show your work. I take it as every problem. So like, how can I show my work with my logical reasoning?
Yeah, you just tell me inside can't be negative. If I go beyond these, it becomes negative, so this is my domain. You can just tell me that.
So just be like, x cannot equal negative 4 to 4?
No. If
they're
I go
showing the word
above
process.
4 or below negative 4, the inside becomes negative.
Right.
So if you do it this way, you can capture your ideas. I didn't show all my work on every problem because I was under a time crunch. I was trying to get as far as I could on this answer key. If you do it the way I did it, you can capture your thoughts, right?
And that'll be enough.
Or you can do it this way, just show the work.
But to capture my thoughts.
Capture your thoughts up here. If I go outside of this, I get a negative number inside, so I
Right.
can only stay inside there. Beautiful, dear.
Okay.
Beautiful, yes.
So for the first one, you're looking on the inside. For the second one, you're looking at the bottom.
The second one, what do you mean second one? The
So
range?
negative x.
The range? Or you mean this guy?
Yeah.
Oh.
Because we're looking
For
the
both of
x.
these, I'm asking myself what must be true. What must be true here? The inside has to be at least 0. What must be true here? The bottom cannot be 0.
Okay. So then, what about the third one? How would I explain the domain?
Is there a bottom to this? Is there a radical in there? It's a polynomial, all reals. There's no part of the function that introduces a problem. This introduces a problem because it has a bottom. Bottom can't be 0. This introduces a problem because it has a 4th root. Inside can't be negative. This introduces no problems.
So you're not looking like at the 3. The 3 and the square root. I mean, the 3 and the 4 have nothing to do with it. Just the inside.
Yeah, this would have to do something with the range, right? What's the smallest number I can get out of here?
1,
If I plug a 4 in, what do I get?
0.
0. So the smallest number I'm getting out of here is 0. What's the biggest number I get out of here? And real quick, you guys see, how do I make this the biggest I could get? Is if I subtract the least. What's the least I could subtract? 0. So then the biggest number would be 3, 4 through to 16. What's the 4 through to 16? What does it take 4 of to multiply to be 16?
2.
So 3 times 2 is 6. And that's why the range is 0 to 6.
Okay. So the inside is for the domain and the rest.
Yeah.
Is the range. Okay.
Inside really is what relates to your x's normally. I don't want to be too specific because some functions get weird. Yeah.
So like if let's just say we wanted to plug in the values of x for the range -4 and 4, would that still give us the answer?
Well, if you plug in -4 and you plug in 4, you get 0 for both.
Okay.
So then the idea is, how do I make this the biggest I can, is to make this the smallest I can. So I need you to understand, you have got to start stepping back and not get too trapped in what's the math I can show, and think instead, is there just an idea here? I'm subtracting something from 16. So how do I make it the smallest? Put the biggest thing in. How do I make the biggest? Put the smallest thing in. That's literally how you get the range. What's the smallest output? What's the biggest output, right? I don't know if you guys are really with me. Yes.
So with the range, it would be the oh no. I was gonna ask, would it be the result of the inside times 3?
Of course. Yeah, totally. Yeah.
Wait,
So
really?
yeah. So the smallest the inside could be is 0. So it goes from 0, and the biggest the inside could be is 16.
Okay.
So it goes from 0 up to that, and that is 3 times 2, 6. 4 through to 16 is 2, times
Right.
3 is 6. Yes?
Oh.
Concept-wise and format-wise, how similar is this practice test to the actual?
Very similar. Obviously, I'm not going to give you the exact same stuff.
Not the same.
But the funny thing is, when you're at the beginning of a class, a practice test is going to look very similar to the test because it's the same type of problems. You know I'm going to ask you, find the equation of the tangent line to this function. It's going to sound exactly, I'm just going to give you a different function, yeah? So there are certain problems I can't change that much. You know I'm going to give you a limit where you have to factor. I'm going to give you a limit where you don't have, you just have to plug it in. I'm going to give you a limit where you have to do, I didn't do it on here, but we did enough conjugate stuff, right? You see what I'm saying? So you know what kind of problem I'm going to give you. Yeah.
And as for homework, so we no longer have to turn up to 3, 4, right? We have to turn
3, 3. Yeah, through 3, 3 is due Thursday. Through 3, 3 Thursday. Sounds like I have a list. Okay. So it's kind of bad that tomorrow, you know, because the Math Science Center is not open, so the whole campus is closed. So
Yeah.
I will have a few times when I will check my email tomorrow. So if you want to email me with questions, feel free, and I'll get back to you when I'm actually home. Is that cool? And then of course I'll be here 8 o'clock on Thursday if you want to come early. Yeah.
Can you go over, can you tell me again how you got the 0 and 6?
Oh. So again, to make the output biggest, I want to subtract the least I can.
So you said 0.
0. So that makes that 3 times 2, 6. If I don't make it the smallest output, I want to subtract the most I can, which is 4, negative 4 squared, right? 16 minus 16 is 0. 0. You get 0. Okay.
I just had a question on the quiz. I thought for this one, I thought grad 2 was a 0, and then I put positive.
Oh, you shouldn't get right to. You plug a 3 in, 3 is 6 minus 2 is 4. 4 is 6 minus 2 is 4. You'll get 0 over 0. So then that tells you have to do conjugate or something. Okay. Yeah.
So my question is about homework, but not like the actual questions, but grading-wise. Is each homework considered 1 point or the amount of questions in the homework? Like if it was 18 questions, is it?
Every homework basically counts the same. So the way I do it, everybody starts with a 100% homework grade. And if you don't turn something in, or if you turn something in and you have to make corrections and you don't make corrections, your homework grade goes down from there. Does that make sense?
So what's considered an okay? Like all the questions done in correct?
That's a little subjective. So there are some people that have gotten okay from me and they made some mistakes, but mistakes weren't that big. So that's a little subjective for me. If you make like a couple of mistakes, but they're both the exact same very important concept, I'll say correct mistakes. If you make, you know, like a ton of little mistakes, then I'm like, should I make them do it over again, or should I just put a little note, you know?
Yeah, so considering the time crunch within today and then Thursday, what I need to do, and honestly speaking, it was just like, if I don't do a couple problems on some homework, would that be considered correct, or like, do we
So here is the life hack for this class. The absolute worst thing to do with homework is turn it in late. If you do as much as you can and you turn that in, I'm probably going to say finish or finishing correct or whatever, right? But then you could get up to full credit. Are you with me? Because you have until the final to turn in the corrections. Somebody, and you know, so as long as you give me a decent attempt at a decent number of problems from every section, I'll say correct or whatever, finish, and then you have a chance to get it back up to full. If you turn something in late, you're never going to have a chance to get it back up to full credit. Does that make sense? So I'm trying to, so everything I do in terms of the rules is to try to trick people to do the right thing to help them out. The more homework you do from more sections, the better you're going to do on the test.
But another question is, what if you don't do like 3 problems? Would you still say okay, or would you say finish?
Depends on if those 3 problems are all related. If they all have the same concept and that's the only problems with the concept, I'm going to make you finish. If they're 3 spread out and you've already done problems like that, I might be okay.
Okay.
Does that make sense?
Right.
Yeah.
Yeah, I asked because there's some problems in the homework at that point. I was just like, you know what? I am not doing it. And
understand.
it was.
I get.
It was horrible.
I was the same way with my